This
and what
conference will
kind of
now be
training
recorded.
they will give. That will be one question, and one important question that will be in your mind, right? At the end of training, what job assistant they will give, what kind of companies come, what is your placement. So believe me, those all questions I am not going to answer. Okay, that will be answered by the one who is like founder of this institute, or else someone will be there who will be presenting this institute. They will answer these all these questions. Sir, what is the duration of the training? Sir, what is the fee cost? Will I get any concession? What I will answer, I will answer you how to make a chip, what we do, how we make chip, how we are changing this world. So that I will answer, that is my part. उसके अलावा जितना है, okay sir, will I get job before 26, after that I want to marry and all those things they will answer. Okay, I will not be there to answer you. Is it clear? Yes. I hope I am very clear. So technical discussion from my side. Non-tech, there are representatives, they will give you the I mean those discussions, those questions, answers. Okay, I hope online attendees you also got it. Your birthday is there today. I thought your birthday also is there. Yesterday, sir. Oh, nice. Sundar. Okay, you downloaded already, right? I downloaded. We'll start. You close your this thing, open this slide for me because see, it is not yet completed already. First you open and then go. Even though I'm like a big techie, I'm very bad in these things. WhatsApp, Insta. Oh. Sometimes my daughter will say, "Dada, a pouch." I'm like, "What is this?" Then she will tell, "Oh, Telegram." So I'm not from that generation, but believe me, I have actually moved tremendously from a generation where I used to write with, wooden pens will be coming. I mean, I don't know. I think you guys are kids actually. In olden days, like 1995, 6 only, wooden pen will come, right? We will drop this ink into that. We call it as a holder pen. We'll put submerge into ink and then take out and write. So that days till now, where I am writing with the help of stylus, where there is no ink, there is no paper, I will write and you will see. So I have seen the journey from there to here. Okay.
Sir, can you please
I
catch up us?
just I feel less than dinosaur or what? That is what you're thinking? No, no, I am not that old. But the thing is, I have been belonging to a place which is not very grown up. Suddenly, I came to Bangalore, which is very grown up. So that transition actually
Hello, sir.
happened from there. I mean, like it is said, no, India is 20 years behind China. Or 50, earlier it was 5 year, 10 year, but because of Corona, we have become like 25 years back behind US and China. Right? Same thing happens with me. So yeah. So yeah, we'll be starting this demo session. I will let you know what exactly we are going to do in physical design. Before going to that, as you already would have done some kind of Google, some kind of Wakai, YouTube, something you would have done. Except this lady, she's not bothered. What the hell you are talking? I don't know. I just came here to join the class, right? So yeah, some kind of, I mean, you would have done some kind of background search, right? And you would have got to know what physical design is a part of VLSI. इतना तो समझ में आ गया होगा ना? This thing you would have got, right? It's a part of VLSI. Now next thing you would have Googled, if someone knows VLSI, then otherwise what is this VLSI? Let's look into that. So you would have Googled what is VLSI, correct? Then in that you would have got to know, oh, it's the acronym of something something very large scale of integration. Then you would have thought what it is. यही तो किया होगा, तुमने यही किया होगा. You can't do more than this, right? Because I had done the same thing. Okay. Can you please open the presenter and also do this present it for other guys. Turn off your this WhatsApp. Okay. Clear enough? Clear. So these things you would have done and you have come here, right? So let's start from there itself. I want to just understand a simple thing. What you got to know when you become a physical design engineer after completion of this course, what you are going to do? That was my question, right? That is the question to everyone. Once you're done with your course, once you're done with your physical design course from here or anywhere, or I mean, I'm not bothering from where you are doing, but you are completed with that course. And let's say without course also, luckily you got enter into some good company as a physical design engineer. What exactly you will be doing there? What do you think?
Just like sir,
Hmm?
just like the civil engineer do for the designing.
तू मेरा लेक्चर देख के आया है?
No, sir.
देख के आया? कहीं ना कहीं से YouTube पे सर्च किया हुआ तुझे मेरा ही लेक्चर मिला है. Seriously? Correct, no? Same example is giving. Okay, anyways. Yeah, sure. तुम कहीं से पढ़ो तो मेरा ही ब्लॉग पढ़े हो. Anyways, So what exactly we do once we become physical design engineer? Online attendees, we are starting the session. Okay. So if you are somewhere missing the audio, just revert quickly. Otherwise, you will miss the whole session because you need to match to my frequency. Because one calculation is there in my mind. You know what? I'm already 15 minutes lag. So I will compensate that. I know where to compensate. Okay. I'm very good into that. I'm expert of timing. Okay. So now the question that is there again, buzzing, buzzing, buzzing. What is this? What we are going to do once we become a VLS? I mean, physical design engineer. Once we become physical design engineer, what exactly we are going to do? One thing you know, we'll make the chip. That is what you told, right? Then I told not that chips, Lays, and I don't know. मुझे Lays ही पता है. Uncle chips. That chip नहीं, potato वाला chips नहीं. What is the chip we are talking about? Basically, we are talking about the integrated circuits. Correct? Yes or no?
Yes, sir.
So at the end of the day, we are going to make integrated circuit, right? That is what we are going to do once we become physical design engineer. So now my question will be, you will be saying me, yeah, how many chip you have made? I will be like, I did some 10 plus projects, I would have made it. Then you will be like, can you show one of your chip which you made? See, India fabrication don't happen. In India, we don't do fabrication. Fabrication happens in US, China, Taiwan. Taiwan is like, there is a company called TSMC, that is a king, Taiwan Semiconductor Manufacturing Corporation. So they make, we don't do that. There are some projections in India also, but I mean currently we are not doing that. Okay, clear enough? So that means what? Then you may ask. Then I mean you are making me fool or what? You are telling that you make chip and again you are saying that you have not made any chip. So what exactly we do, as he was trying to help with the same kind of similar kind of approach and similar kind of answers, I will tell you what exactly we do. Okay. Before that, I want to understand what is VLSI because we will be starting everything from there. I have just, I mean, I'm not a big follower of PPTs and all. Just thoda ye colorful lagta hai, so I put it here. Okay. So let me know. Same query to you guys also. What do you mean by VLSI? Even online attendees, please be vocal and please be, I mean, please ask questions, please give answers. As simple as that. What do you mean by VLSI?
This is the fabrication, the process of fabrication of many integrated chips, like lakhs of integrated chips.
Lex. Okay.
Lakhs or thousands of integrated chips.
Speak up.
Same way.
Integration of what?
Transistors, diodes,
बहुत अच्छा. This is what answer I wanted.
transistors.
Okay. So basically VLSI, I will write little bit just to show you how bad is my handwriting. Okay. So VLSI you can write down if you want. See, generally people think that first lecture they will not teach. I teach in first lecture. Okay. I will give you a demo. I mean, at least you will understand the flow. Okay. See, I do follow a principle called as WWH. That is my principle. What, why, and how. Okay, what is this thing? How, why this thing, and how we are going to achieve something like that. This kind of thing I follow. Similarly here also, if someone tell me, I mean when I was like into my BTech final year in 2014, 15 pass out I am. So that time my brother told that try to go into this field because you are very good and you have a very good knowledge of something. I will tell you what kind of knowledge needed. Then he told you go in this field. I asked him what is this VLSI. He told it's a very large scale of integration, and he told I'm gone. Okay, so that is one approach. That is the approach with me also. I will also be teaching same way. I might not be teaching you or someone else, but yeah, that is my approach. I give a question, that's it, done. Now you need to go a little bit of workout you need to do. But today I will help you at least for the day. Very large scale of integration. First thing, what is this integration? First question that should come, right? So one thing is for sure, the statement and the acronym of this thing is showing that yeah, very large scale of integration. That means something we are integrating. Integrating matlab summing, right? See, at the end, integration is nothing but a summation from zero to infinity of small quantity. That is what the integration is. Summation of area, yeah, that is what the integration is. ये तो करते थे mathematics में. In mathematics, that is the integration. Here also same concept will be applicable. Integration is small things. We are actually trying to make it a bigger quantity with that. Clear enough?
Yes.
Clear enough?
Yes.
Bye. Okay. So integration of what? Then these guys told us, sir, it's transistors. It's transistors. Everyone told transistors, transistors, right? Correct? So yeah, you are correct. It's an integration of transistors. So that means if you actually use transistors and if you do some kind of connections, at the end of the day, you will make some logic, some hardware which is going to be equivalent to logic required. Like I want a logic called y equal to a and b, let's say. So we will do such a way that the transistors will be connected in such a way that at the input if I give a and b, at the output I will get y equal to a and b. Correct? No, that is what we are going to integrate in such a way. Correct? Concept is clear till here. So this is what the VLSI is. It's a large, it's integration of transistor at a very large scale. Okay. Now, once what we will be doing in this, I will discuss about that. But the point is, when we are integrating a transistor to a large scale, what we are going to make with that? We'll make some entity. I told one single entity will make. That single entity we call it as a IC. Okay? I hope online attendees, you guys are able to hear me clearly, right?
Sir, we are able to hear, but not able to see any video.
Huh? You are not able to see anything. So what
Yes.
he
Okay.
did?
Yes, sir.
So
Oh,
Your
in
camera is
chat
off,
we
sir.
यार तो पहले बोल दिया करो. That's what I told. If you are missing anything, if you are, I told in starting only, I'm going to write something. So that means obviously I'm writing something. So you need to tell. Now you are able to see, I guess, right? You are able to see, right? I
yes.
hope so. Perfect. So till here, I hope you didn't miss any of the bridges. You connected everything, right? Correct? Because nothing was taught here, man. I just told you what is VLSI. Is it clear till
Yeah.
here? Now how we go, the approach should be in this way. Okay, someone is saying integrated circuit. What do you mean by integrated circuit then? Correct, no? So if I ask you circuit, what comes in your mind? What comes in your mind when I say circuit?
Creation of RLC.
हाँ, उससे ज़्यादा तो नहीं आता होगा ना. That is what comes in my mind. So if I were there, I'm not that smart enough that you guys are. Maybe today's generation is more smarter, right? So this thing only will come in my mind, right? Something like this, something like this, something like this. I will like, what the hell, man? Again, same thing is coming. I wanted to avoid it, right? So this is one of the circuit, right? Then this circuit and our circuit, how it is differed? Integrated circuit, is it different from this circuit? See, if I want
Yes.
to implement this circuit, how I will be implementing? If you remember breadboard experiment, so in breadboard, if you remember those experiments when you do in the labs, you will be having something, some kind of structure, something like that. Breadboard will be there, right? You will connect some wire, and with that wire, whatever, if you want, you can connect wire and some power supply. If you want 5 volt battery, something like that. And then if you want to connect some resistor, you will be connecting some resistor, something like that. So then finally, this will be making the same schematic. Is it clear till here? Is it clear till here? One energy source is there, one power source is there, and the other is the load. As simple as that. This is also a circuit, correct? But I am talking about integrated circuit. Okay. So till now, at least you got. This thing you know, right? In mobile you are using ICs. In laptop there will be ICs. At least you got to know this much. Okay. So what is your good name? Okay, Pushpa, if I am telling you from this breadboard setup, can you take out 1 kilo ohm of resistor? Will you be able to do that? Correct? Some color coding will be there. You will calculate and find, okay, this is the one, or else it will be written also sometime. I will take out. Don't give me. But if I am telling that, Pushpa, do one thing. Take out your mobile and from there, can you give me 10 kilo ohm of resistor? You got my question?
Yes. Already inbuilt.
It's integrated, that means it is fused structure. Here it is discrete. You can take out. But in ICs, what I can, all the active and passive element, they are fused on a single surface. That we call it as a wafer or the die. So when active and passive elements are fused on a single surface to make a closed circuit, it will be called as integrated circuit. There is no hard and fast definition. You can write it if you want. इतना समझ में आ गया? Is this clear till here? Now when it comes to this ICs, for example, you would have done experiments like IC 7432 OR gate, correct? No, and IC 7400 NAND gate, correct? This thing you would have done at your BTech and all. I also did. I think in 2015 I did this. So I remember the 7432 7400 at least. This two correct hai pakka. Okay. So in that, if you remember the experiments, what our teachers used to teach, that we never understood that time. Correct? Did you understood that time? I never. So there will be like some black color such kind of structure will be there. ये red बना दिया, इसको हटा देते हैं. Okay. Okay. So something like this it will be there, right? One cut will be there, and then you will be having some golden color, some output, something like this. You remember? And here it will be written IC 7432, something like that.
Yes.
You remember this thing? So this was one of the ICs. So your teacher will say that go and bring that. Now VDD VSS will be there, connect that, and then some inputs you connect that, and you will be like what? And for 45 minutes you are doing the same thing in the lab and never understood for entire career actually. Correct? So that was the IC actually. That IC will be made by engineers like you at the end of the day. Okay. But that small IC, if you think it like that time only it was small, now it has become very small actually. That whole process will take like 6 to 8 months to make. So we need to understand that flow, that cycle, and where actually you are actually falling in that cycle. That we need to understand. Is it clear till here? Pakka? So at the end of the day, you will be making the chip only. But you as a physical design engineer, what you are going to do, that we will discuss. That is the main agenda of today's session. That I need to make you understand. What will be your role? Is it clear till here? Can I move forward slowly? We have already discussed this. I told you, correct? What is the difference between normal circuit and integrated circuit? I gave you a little bit of idea. In normal circuit, at least you can take out the element individually. They are actually discrete. But in a integrated circuit, you can't take out the element individually, right? So if you talk about the ICs, if I talk about the evolution, since you told that it's like integration of transistors, so you may think that how many transistors needed, yeah? You may think that. Is it like 2 transistors? Is it like 4 transistors? Is it like 10 transistors? See, you can make a small chip with the help of some 20 plus transistors also. Correct? No. If I ask you how to make NAND gate using CMOS, you can make it, right? So you can think how many transistors will be needed. Correct? But there will be chances. Let's say I'm telling that you have to make Snapdragon 888. That is the latest processor actually. She's thinking what it is. I know Instagram, WhatsApp. What is this Snapdragon now? Snapdragon processor. Okay. Okay. So in that billions and billions of transistors are there. So based on that, actually there is a family of ICs. So evaluation happens from 1960s till now. 60s was the period when we started making smaller chips, first chip you can say like that. Correct? Now just I have put a slide for you for understanding purpose. That is not the part of demo. The demo part should be I should tell you the institute wise, but I am not the. I want to make it worth it. At least I traveled for 10-12 kilometers, so at least technical discussion I want for 1 hour. Okay. So this is what the family of integrated circuit is. You have heard and you have learned this in BTech 7th semester, 6th semester, MTech 2nd semester. You would have heard it. As simple as that. सबको पता है थोड़ा बहुत at least. Like if it is a small scale integration, so some less than 100 transistors are there or components are there. Components means transistors here only gate count. I can say yeah, it is like a small scale integration. Similarly, the order changes and when we come to VLSI, it is like more than 10K. Now in millions now, more than 10K. Correct? That is VLSI. There are new things also. I mean, don't worry about that things like ultra scale, giga. I mean, there will be chip when it is needed like more than that transistors also. Like that is used in PSLVs, like satellite launch vehicles and all those things, right? So there will be like compact actually. It required a lot of computing, a lot of algorithms. So they need more number of transistors into that.
What designed those ICs, sir?
Hmm?
What designed those ICs? Rocket, rocket ICs. Not designed.
People like us only, man.
Which company?
No, so that is one thing you need to understand. So good question he has asked. I mean, I will answer it, but in a different way. He asked who designed those chips, sir? Because see, because that is something that is related to the national security, right? So we can't take help from China. Somewhere we can't take help from US also. We can't expose this thing. So there will be like in VLSI also there will be persons who will be doing freelancing.
No, but you told in India they're not.
So that's what we'll come to. In India we don't do fabrication, okay? We'll take help from other. That's what fab houses will be somewhere else. We will actually design it. Okay, we'll give our design and tell them you give me the physical form. So that's what he was talking. Civil engine. I will come to that. I'll come to that when I will teach the flow. I'm just giving you an idea till now. Is it clear? In India, we don't design, but we can take from some vendors. Will be there. No, outside India, we can take it. Right? We'll give them the design. We'll tell that make it and give us. That's as simple as that. You got it? Clear enough? I know you don't know about fab houses, fabrication, you don't know that much, but I will give you an idea, don't worry. That is what the agenda is. So you are asking about the desert in starting only, you don't want to eat the main course. Huh? That is the end discussion you want to do only. So how we have
In a
explored
laser
how
sword,
what the trend is, right?
identify two ways to declare a fixed-sized array. Explain what
Sorry,
happens when you read or write.
can you again come back again? I think I lost your audio. Can you please ask your query again? No, someone was trying to ask. Okay, move forward. And one more thing, I will ask questions. You can revert it right away. But if in any chance, I mean, if I miss your question, something at the end, you can again discuss. No problem. We'll come back again to the same thing. So, no, this is just a slide to make you understand from where to where we have reached. Just to make you understand the wonders that VLSI is doing. Even this is not also. If this don't make you crazy, you can think of latest phone. And if you remember 1990s, the Nokia 3030 3310, you remember those phones? Huh? A kind of bulky phone. If we hit to this lady, you know what will happen. At least she will not be able to take that force, right? It's very heavy actually. Correct? Nowadays, if you see this iPhone and all, I mean, any phone, if you say very slim, very small, right? And fast processors, even the computing will be very fast. Big game, heavy loaded game you can play into that. And other olden phones, you remember, they were like based on Java. If you play this snake game, also it will hang sometime. That snake is going to eat something and suddenly it will hang. Correct, no? So olden days, nowadays the things have changed like anything, right? Here one example they have given. ENIAC was the first computer, if you know. It was like it was as big as one room actually. Now I'm teaching you. See how many computers you have. I'm teaching you on one laptop. I mean it's very small, right, compared to those days. Correct? So things have changed from there to here. Okay. Even what future hold that I have written, right? See, this is not actually future. If you talk about future, I will talk. I mean, I will talk about few things that is happening in the market right now, but just giving you an idea till here. If you remember, I mean, obviously this is like very connected to you. You remember floppy disk, correct? Everyone remembers floppy disk. So the size will be like 4 KB, but the actual physical size, you see how big it is. But if you see nowadays, 1 TB memory card, how small it is, correct? Even I remember like 2011 when I was actually preparing for IIT that time, we used to buy this memory card of 512 MB for some 400 rupees, correct? No, and for completely they will be uploading the files into that. For that they will take some 250 rupees. Sir, we will full it completely. Good Aarti Faslan song, correct? No, now it is 1 TB memory. And even if you see the speed, that day if you give that chip in morning, in evening, you will say that sir, we will fill and give you in evening, right? Correct? Nowadays, what will happen? See, what is the speed of internet you are getting? Correct? No? Fiber net. Correct? Gbps speed you are getting, man. Now, what is Gbps speed has came? In olden days, not olden days. If I'm talking, I'm not that old, right? I'm talking about 95 only. That is just 15 years back only, no? As per calculation, 10, 15 years back. 10, 15 years back, the things were so. I mean, see how old you are, how technology has grown. In 10 years, your hair has not grown that much. The technology has grown very fast actually. Things are happening. I will tell you one example. I don't know whether you know about this thing. How many of you know about AR and VR technology? VR, you know, right? Virtual reality, you know, right? How many of you know virtual reality, augmented reality? Some idea? You know that, right? Now you see how much things have changed. So, what is this VR and AR? It's very simple actually. I think you all will be fascinated with good songs, no? Bollywood songs, Kannada songs, Telugu songs. In that the poet or the singer will mention, no, I will come in your dream, I will do this thing, that thing in dream, right? Khwabo khayalon mein, right? Such kind of things. That we literally took it seriously. We VLSI engineers took it seriously. We'll tell that, okay, what is your dream? Your dream is to go to Eiffel Tower. Okay, let me make a technology. When you use that technology, you will directly feel that you are at Eiffel Tower. That is what the VR is. There will be one big spec. You can Google and see. One spec will be there. You would have done, right. You go to mall, you will find those kind of things, right? You will wear that spec. I mean, full gadget will be there. I'm telling spec and spec, but there will be one complete gadget, right? If you wear this and they will play the video of Eiffel Tower or something like that, you will go to that place, right? You will feel that I am there. And when you turn right, you will see some building. When you turn left, something else. If you see bottom side, something you will see. So that is based on completely on your technology. It's a combination of VLSI plus other technology, that is machine learning and AI is right now. Correct. So think where we have reached. Correct. But that is not the end. Then we thought, okay, if we can enter into someone's world, why can't we bring that world to us? We thought this way, okay, we are wearing a gadget, okay, and we are thinking that, okay, I have entered into a place where Eiffel Tower is there, I'm exploring that place. Is there any way I will be in this world only where I'm teaching to you guys, and suddenly Eiffel Tower will come and be here? Are yeah, you have seen Iron Man, right? In Iron Man, what he says, Jarvis, can you please project this thing? So Jarvis will project. Sir, see, this is the building, this is the entrance. For here, four soldiers will be hologram, right? You remember? So that is what the augmented reality is. There is a gadget actually. Google has launched Google Lens, I think. No, not Google Lens. Google, I forgot that complete name of that. It's like very costly actually. Google Lens to एक app है actually. Forgot the name actually. So if you wear that, okay, and if you click that, what will happen? The hologram will come at the table only. India Pakistan match you are seeing there only. You are understanding, right? The things are changing like anything. So now we may think, these are like what it is. I mean, what we will do with that? But you think in this way, it can bring wonders, man. For example, see, right now a lot of you have heard a lot of animals are getting extinct, right? Just now that one news was there in the market, no, Kunu something, right? They have brought some 12 cheetah or something in India, right? There was a news, right? Why it is happening? Because that complete species is actually extincting. So we are bringing them, right? That is what happening. No, some news was there. I don't follow that much of news nowadays, but it was there, right? So similarly, let's say I want to bring dinosaur. Simply, I'm saying, can I bring that? In reality, you can't bring because it is not there only. But don't you think that with the help of AR, still it is possible? So kids will be able to feel that, right? So we can do a lot of wonders with that. Even I'm just giving you a fun activity, fun idea, but you can do a lot of wonders. So there we have reached. From where to where you think? So a lot of guys will ask, sir, is technology going to freeze? Is it like we don't have any future? Like that, a lot of questions will come. Guys, I mean, even we have not started manufacturing chip in India, okay? And the other part of the world, they have reached to that level, you see. So what do you think? You have future or not? Obviously, your future door is still not open, man. We are not manufacturing a single chip in India, and in other places they have done the wonders, right? So obviously we have something, right, in our plate at least. Is it clear till here? So this is what from where to where we have reached. Okay, just wanted to give you a feel. Once you become PD engineer, what wonders we can do. So this was just the starter. Okay, now we'll go to the main course. We'll move, and I will come to the desert part, which I discussed to you. So what we are going to discuss now. Now I am going to. This was just the starter. I wanted to build up this session. I hope everyone is towards me now. Correct? No? Your chat is over. Chatting done. Insta, WhatsApp, Facebook closed. Now concentrate on me. Okay. So now we are going to discuss how we are going to make the chip. Okay. And where we physical design engineer come into picture. And even in VLSI, there are different domain. You would have heard that. But you choose physical design. I don't know whether you are confused or you are crystal clear. That I don't know. And 95% of the time you will be like confused or you will be like pushed by someone, go to this field. This is
Sir,
not
video is not visible.
sorry.
Video is not visible, sir, to online students.
Video is not visible.
Video is not visible. I am not showing any video. Just this you can see the paint application.
Yeah, we can see the paint application.
That's what
Yes,
I
sir.
am presenting, right? There is no video, there is no PPT. That paint. I'm going to discuss that. Now I'm not going to use any PPT. Okay. So the point here is, I wanted you to understand whether why you choose physical design. First, you need to understand that. That's what I wanted to make you have a feel of that. Believe me, you never came by choice. If this was case, everyone is saying I'm 2018 pass out, I'm 2020 pass out. You would have come that time only, no? You got my point? So because of something you came here. Now what is that motivation? Is that motivation is a monetary part, or that motivation is now I'm fed up with IT, I want to come into VLSI, or motivation is something else? I don't know. Even I know what you think, but we need to understand that. And second part, there will be a lot of confusion with your mind. Someone would have told physical design, but you will think that, hey, I am also good in programming, so does it require programming? And I'm not good in programming. If I'm not good in programming, how I'll manage this? So you need to, I mean, have an understanding of that, right? So for that, I need to explain you. Okay. So end product is I want to make a chip. Okay? Correct. So from where the chip designing start, or from where any kind of product start. For example, I have to make a product. Okay. So it will start from where? Huh? Very good. Some planning, some idea will come into my mind. Correct? What is your good name? Harish. So Harish is saying some planning is needed. First thing is that he is very clear with that. Okay. So that means I'm saying some ideas would be there. Okay. So he's like, okay, Zia, I give this example every time, so I'm giving again. So he's coming and telling me, Zia, do one thing. You are very good in VLSI field. I have heard your name a lot. Can you do me a favor? I'm like, yeah, what favor you want, Harish? Tell me. Sir, what I want once I complete this training, I want to enter into my dream company. What is your dream company?
Qualcomm AD.
Qualcomm.
Qualcomm already.
Okay. Analog devices or Qualcomm is saying. Qualcomm is a bad choice. I'm just saying, I'm just joking, don't worry. So Qualcomm are analog devices. He's saying that that is my dream company. Okay. So now let's say he completed the training and he got into Qualcomm. Don't worry, 40 of my students are working in Qualcomm whom I have taught. Okay. So that dream will come true if you really focus. So
Excuse me,
Qualcomm
sir.
he ends. So he get a job in Qualcomm. Okay. Now that is his plan. Again someone wanted to say something, right?
Not able to
Guys,
see your paint boards. Not able to see your paint board, sir.
Your pain.
I'm not writing anything. I'm just discussing. There are audience here also physically present. Okay, so I'm just discussing. You just be in sync with the narration. When I will start writing, obviously you will see, and I will ask also whether it is visible to you or not. Right now, it's just the
Okay, sir.
narration. I'm talking. Okay, I'm trying to demonstrate or illustrate. When I will write,
Okay,
I
sir.
will ask you whether it is okay. Since you say
Okay.
that not able to see, but now you are able to see this, right? Something I made, man.
Yes, yes, we are able to see.
Yeah, yeah, I am very sure it is not Mona Lisa, right? Okay, okay, okay. So Haris is saying, Zia, what I want at the end, once I complete the course, I want to crack interview of QC. And once I crack this interview, since I belong to a very humble background, my parents have put a lot of effort. Even after completion of my BTech, they are paying fees for this training. What I want, Zia, can you help me with one thing? Make a small chip. When my mother is coming, no, doors should open and flowers should fall. Perfect idea, no, Harish? Correct? It will become romantic when the girl will change from mother to someone else. Correct? So, but his point is, when my mom is coming, mom को थोड़ा बुरा बना देते हैं यार, गुस्सा मत होना, okay? Wow, this is like village mom, na? Very laborious working woman. I hope you are light-hearted. Don't take it like seriously. Why he made my mom like that? I will kill him. Huh? Don't do that. So he's saying that when my mom is coming, since I belong to very humble background, she has put a lot of effort to make me like this. Once she is coming, I want to tell her like, see, this is what I'm doing, and I want to do with the help of my technology because I am a technical person. So if door is there, Ria, can you do one thing? Make one chip. It will pursue something, and door should open and flower should fall. That is what the idea is. Correct? No? Perfect. So Haris has told this thing to me. Now I will be the one. Okay, I will say yeah, we'll make it. Okay, we can make it. There are a lot of things. You know this thing can happen, right? PIR sensor, passive infrared sensor. If you do motion detector, a lot of things are there, yeah, in the market. But his point is, don't buy it. We'll make it. That is what he's saying. So I'm like, okay, we'll try that. So I will ask, like, okay, did you gifted something, some mobile to your mom? He tell, yeah, I gifted one mobile. I will say, okay, can you tell me specifications? What are the mobiles? So that I can plan something because you exactly want your mom should come and doors should open. So maybe, I mean, I'm just giving you some hypothetical example. Maybe I will pursue the bandwidth of each and everything. Some specific application, let's say I will tell him download some tracker. Let's say mom tracker, there is application, can you download? It will actually emit a frequency of some 212, let's say megahertz. That is very specific to that particular bandwidth, which will tell that this is your mom. Assume that. That's just the assumption. Okay. So I'm writing like if the bandwidth is equal to some 212 megahertz, that means what, the mobile belongs to my mom, right? Then what you do, I'm telling that door should open, something like that, okay, else door should be closed, door remain closed. Some logic like this someone will write. Now will I be the person as a physical design engineer to write this code? No, we don't do that. We don't do that. But obviously logic is needed, right? Because a chip is nothing but a machine. And machine, if I tell that, hey, listen one thing. When my mom will come, you have to open the door. Machine will say,
ఫోన్లో
I'll
బ్యాలెన్స్
give you a
లేదు.
right, okay. Correct?
తమ్ముడికి ఫోన్లో బ్యాలెన్స్ లేదంట. తన దగ్గరే అన్నాడు. ఉపయోగం ఉంది దాని వల్ల తీసుకుంటాను అన్నాడు.
Madam, you
డబ్బులు
talk to
ఉన్నాయి
your
కదా.
kid or maybe someone else, but you please mute it. Let's listen to her and translate for me. Something good. Everyone is mute. Can you please mute yourself?
ఎప్పుడు వచ్చారా?
I have to mute this. This is one thing of online classes, man. It's okay. Is it okay till here? Where were you, man? When I forgot. Logic. Acha. So we want that logic because see, machine only understand what machine language. If I tell that open the door, machine will be like that. That also can happen nowadays with the voice modulator or something like that. I can do that, but at the end it will be converted into machine language only. Correct? No, yeah, simple, right? So what I am going to do? This logic need to be converted into hardware form. Correct? If I ask you this logic, what hardware it will make? What hardware it will make? This logic, what hardware it will make? See, you have learned everything. Only thing you are not able to imagine that. If I will make it, no, you'll say, yeah, it will make. Huh? No, which digital logic it will make? It will make a mux map. See, na? Very simple. If I say that bandwidth, something like that, bandwidth. If this bandwidth is equal to 212, then what will happen? This logic will come here, or else it will not. I mean, it will make mux only, right? You got my point. So at the end of the day, it is going to make the hardware only, right? So that logic need to be written by someone. So in VLSI field only, there will be coders, the one who writes the code. Coding is what? It is nothing but your logic only, right? Correct? Yeah, if I ask you 2 into 5 equal to what? What is 2 into 5? 10, because you know the table. But if I ask to my daughter 2 into 5 equal to what? She don't know that multiplication. Then I will tell, beta, you know addition, right? You do one thing, you add 5 times 2, you will get the answer. Correct, no? Yes. That is the logic I am telling, na? For I equal to 2, I is less than 10 and I equal to I plus 2. Correct, no? That is what I am telling to my daughter, right? That is the logic. So coding is all about logic, how your aptitude mindset is going on. So that coding we can bring into VLSI also. Because logic wise, so yeah, everyone is same. I have heard a lot of guys will be saying that, sir, I'm mechanical engineer, but I'm working in an IT firm. Because it can happen. It can happen. Mechanical, civil, they can work in IT. You got it right. But we prefer someone who is from our background only because Other knowledge will be really helpful. But if only logic, anyone can be good into logic, right? Is it clear? Coming to this part, now this logic need to be written, correct? So there are coders who write the code. So in VLSI also we have the engineers who write the code. Okay. So for writing code, they can use C, C++, Java, COBOL, whatever language they want, they can read. Right. The problem is the compilation of the code that it when happens, the library is not in such a way that it will make the hardware. The C, C++, Java, it is not going to make the hardware actually. So for that, there is evolution of languages that make the hardware. We have something called as HDL, Hardware Description Language, or Hardware Descriptive Language. Just Google it. I'm not more into that. So HDL. That means a language which is going to be used for formation of digital circuitry. Is it clear? Or I can say hardware circuitry rather than saying digital circuitry, because we can actually write the transistor also in this. So hardware description language. Example is Verilog and system Verilog. So the engineers who write the code, they will be using this kind of coding language to write the code, and those guys will be called as front-end design engineers. Okay? Okay? Can I move forward? I'm going to delete it. Can I do that? I'm going very slowly. You don't worry about that. Fan on कर लो ना यार, क्यों मर रहे हो? तुम लोगों को गर्मी नहीं लग रही क्या? You guys are not feeling suffocation in this room? No? मैं मर रहा हूँ यार. Junaid थोड़ा help कर. No, be there. Junaid help. So Harish, you started from idea or specification, right? Then first thing what I told, you asked this Satish actually, he will help you. Then what I told, ask to Satish, no, he will help you. I think regulator only need to use, I don't know. Maybe light ही नहीं होगी in game. Okay? Fine. So idea or specification, the idea was you wanted a chip, when your mom is coming, door should open, flower should fall. That was the idea. Then there will be some requirement that I will ask, how big you want. Then you will tell like I want this much big. Then I'm telling that okay, which technology you want. He's telling that sir, we will do one thing. Whatever the frequency of that wavelength of this, frequency of that app it is coming. That kind of technology we need to work. For example, I'm telling Bluetooth technology. So that he will tell that we will work on Bluetooth technology. So Bluetooth technology will be having some specific kind of bandwidth, right? 2.4 gigahertz or something like that. That is the specification of the device. Such kind of specification I will get as a raw in starting. Okay. Then I will move and tell that can you please, there is someone who can write the code. Yeah, there will be engineers who will write the code using what, which kind of language? HDL, hardware description language. Example is Verilog and system Verilog. I gave you two examples. Okay, this one I want. I hope you are okay, right? नहीं तुम तो ओके रहोगे, उस लड़की को पूछ रहा हूँ मैं. Fine, right? We'll move forward. Let him do his task. So Verilog and system Verilog. Now I wrote let's say I'm writing one small code for you. Don't worry, you don't need to write this kind of code. So one syntax I'm giving you. Let's say I'm writing one code. Output wire is A, B, and then what it is meant, and A1 or AB, something like that, and module. So this is, let's say I have written a code in Verilog, simply. Okay, don't tell me, those who are from MTech or something, they will tell that, sir, here you have missed this syntax, here it is wrong. Guys, I'm not from front end, so it's okay if I miss little bit of things. So I have written this code. What it is going to make? It is going to make a AND gate. Now Harish is saying, hey, this guy don't know how to make AND gate and he's going to teach VLSI. Harish, don't worry. I know how to make. But I will ask you, what is an AND gate? This is, see, one more important thing. If your dream is Qualcomm, you be ready with this kind of questions. I will ask this kind of questions only. If I am asking, then many of them will ask. Because I am the one who takes better interviews actually, or toughest interview. What is an AND gate? Very simple question. I will start from there. This is a box, dabba. Correct? No. I am telling this dabba is nothing but an AND gate. Okay, Haris? Prove it. You got my point? Someone has written the code. In which language he has written the code? Some gibberish for me. I don't know which language. Verilog is nothing but nothing. I mean, you don't know this language, right? When I enter into Bangalore, I was not knowing Kannada. Correct? No? So that is some language for me that I don't understand, right? Correct? You got my point? Same here. I don't know. Then how I can be very sure that he has written the code for AND gate only? I can't be sure, right? Correct? Then what I need? Correct? Pushpa, I will call you. I will tell Pushpa, can you please translate this Kannada into Hindi or English? She will be translating that into English because I'm able to understand English. Okay. So she will translate. I need someone. I need someone to verify he is saying correct or not. Correct? Same thing, whatever this guy has written the code, it is correct or not need to be verified. And how it can be verified, Haris? If I give 0 0, output will be 0. If I give 0 1, output will be. If I give 1 0, if I give 1 1, what is AND gate? If both the inputs are high, output is high, it is AND gate. If both input are high, output is high, it's AND gate. Is it correct? Is it correct? In OR gate also it happens the same. Then you need to define other things also. Other combinations should be low. If any of the input is low, then output will be low. This is a pakka AND gate. You got the point? So you have to play with the English in VLSI. You should not be very good in English. You should be very good in concept. This statement proves you, right? Your English is correct. If both input is high, output is high, it's the AND gate. If statement is correct, logically it is wrong. Because in OR gate it can happen, in other combination it can happen. Correct? So if both the input, if any of the input is low, output is low, I can say it's an AND gate. That is for sure. So I can test this way, no? I can give A, B and some Y and I'm saying 0 0 0 1 1 0 1 1 0 0 0 1. If this is my required output and I'm getting by giving and toggling this value, I can say that this is a AND gate. I can say that. That means I need to verify it. Whatever logic you are writing need to be verified. So for that we need engineers who will be writing the codes to verify. See, for verifying what I'm doing, I'm giving some value and verifying it. That value I need to write in some code that is called as test benches. They will write the test benches. Okay, in that the input values combination will be there and output they will capture. If output is matching to your required or intended value, you will say that yes, the logic is correct. Is it clear till here? Those guys who verify the logic, they will be called as verification engineer. Is it clear till here? Any doubt? Any doubt till here? Perfect. Now I am moving forward. Now your code is written, it is verified using test benches. So now someone can ask, sir, how they will write verification? I mean, how they will write this 0001? They will write the test benches using same coding language called system Verilog or Verilog. Okay, same language can be used to write the test benches also. But the problem is the advancement has happened actually. See, there are two input. Then how many combinations you have written? 4. If there are 4 input, 2 to the power n. Everyone knows that. 0, 1, the 2 to the power n combination. Nowadays, you know how many pins will be there for a device. 128 pins, 256 pins, that kind of thing. So you can calculate 2 to the power 256. Give it to your calculator, it will die. If you give this value to your calculator, calculator will say that, okay, I'm going to hang myself. It will actually hang. That is what you say, hanged, hanged. वो actually में hang रस्सी लेता है और hang हो जाता है. Okay. So this is very big number, right? So you will not be able to write the test benches for that, right? So for that other methodologies has come. Even here also they will be teaching, right? OVM, UVM, you would have heard UVM, Universal Verification Machine, Open Verification Machine. Some methodologies they have developed to incorporate this kind of big combinations also. So they will be teaching all these languages in front end. These are called front end. I will tell you what it is actually. Where your code is visible to you, what is happening, all those things will be visible to you. Is it clear till here? Is it clear till here? Any doubt? I'm giving a break of 2 minutes. Just think once and tell me if you have any doubt. This is the worst part of Bangalore. If you turn on the fan, you will start feeling cold. If you don't turn on, you will feel it. Is it clear till here? Pakka? Okay, we'll move forward. Okay, so Haris has told me to make this chip. What was the requirement of Haris? Flower should fall. So he has given that requirement. He has given that requirement. Let's say in 2020, something happened for 1 year. He did not get placed. Something happened. Okay. Now, after 1 year, 2 year, he met me and he said, "Hey, Zia, can you please quickly teach me everything?" And I am like now ready because I was. So this is the reasons you guys give no, sir. From past 2 years, I was doing gate preparation. From past 2 years, I was doing EPSC preparation. I was into IT. Now I came something like this. These are the valid reasons only, right? Nothing else. If I ask you why didn't you enter into VLSI in 2018, you will be like, sir, I was preparing for gate, or else I was preparing for UPSC. Or else we'll say that, sir, I was working in IT domain, now I want to switch. Correct? No, these are the reasons. Apart from this, anything else? I married that time, now I'm going to work. Not that reason, right? Okay. So yeah. So now he's telling, yeah, now I'm ready. I want to work with you. Can you please make this chip? I will be like, man, that time when you told, the technology was different, right? Now technology has changed. And why this technology has changed? Why this technology is shrinking? What is this term called as technology shrinking? Moore's law तो उसके ही कंपनी वालों ने फेल कर दिया यार. Moore's law is fail now. What he told after 18 months chip size should be double, ये बोला था ना. सब fail है आज के समय में. Nowadays it never happens. It happens in some 6 months only. Now it is saturated also, so it is different thing. Why it shrinks? I will tell you. See, what is this technology actually? Earlier in the olden days, what was happening? This diagram you remember, I hope, right? Source, drain, and gate, correct? कुछ होता था ना ऐसे P substrate something like that, correct? So when you give positive voltage, it will repel here, inversion layer will be there, and then channel length will be formed. That is what happened. In short, in a nutshell. I'm not going depth into that. You will learn it. How a MOSFET works, man. I'm not going to discuss that now. So now this channel length will be formed, right? This channel length was nothing but earlier called as technology node till 45 nanometer. So the length of this channel length was called as technology node. Like 160 nanometer, if I ask, this is nothing but your channel length. Okay. So it started shrinking actually. Okay, now they have read because see, we can actually reduce the size of transistors. So they started doing that, and they started and gone to some 90 nanometer. Then they have come to 60 nanometer. Then they come to some 45 nanometer. Done. Some 16 nanometer. What is the latest technology node? 3 to I'm working. 3 nanometer I'm working. So 3 to hai. Okay. So 2 is already announced. They are doing test chip on 2. I'm working on 3 man. So 3 तो है ही. 3 का तो छोड़ दो. I tapped out 5 nanometer. तो 3 पे तो मैं काम कर रहा हूँ.
How much more can I select?
You have seen that movie Lucy? Scarlett Johansson.
Yes, Scarlett Johansson.
You have seen that? So her brain start like 80%, 70%, 90%. Once it become 100, what happen? She's gone, right? Same thing will happen. When I mean that is what the projection is. Once your technology shrink to maybe less than 1 nanometer, obviously you can't deal with particles, right? So wave will come into picture. Quantum physics. Yeah, quantum physics is there. No, that will come into. I mean, that is what the projection. Forget about that. Abhi isme zero yaar. Okay, is it clear till here? So it is like 3 nanometer and 2 nanometer are like latest technology node. See from
sir.
where to where we have reached here.
Hello.
From where to where you have reached? From 180 nanometer to 2 or 3 nanometer, right? Yeah, someone was saying something. Can you please go ahead?
Sir, am I audible, sir?
Yeah, you are audible, man.
Sir, those nanometers in the sense the distance between the source and drain, right?
Sorry.
That nanometer in the sense that 90 nanometer, 60 nanometer in the sense the distance between the source and drain.
Yes, that
That
is
what
what
you
the
saying?
channel length is, right? The
Okay, sir,
distance
I'm clear
between the
now.
source and drain, the channel will be formed. That is what called as your technology node. That is what defined at nanometer. Like if you ask to VLSI Guru sir, what project you guys are doing in physical design. They will tell, na, we have a very good project of Orca top, we are doing it, it is in 28 nanometer or 32 nanometer. Then you will be like, what is the 28 nanometer and 32 nanometer? So before 45 nanometer, it was channel length. Now because of some kind of new technology called as FinFET has came, there is something called FinFET now. We don't deal with MOSFET and all. There is something called FinFET, where we have like more than two gates, tri-gated device or gate all around device. So there the concept has little bit changed. Not exactly gate length, it will be little shrink that. That means 45 nanometer. That means channel length is 45 only, right? But nowadays, if I talk about 16 nanometer, then you may think that channel length is 16, but it is not 16. It is scaled a little bit. It will be somewhere around 10 nanometer or something like that. Scaling has been done because of 3D dimensions. Earlier only one gate, two gate maximum. Now there are like gate all around devices. Okay, so a lot of advancement has happened that you will learn in your real advanced physical design course. I'm not going to discuss that, but just give you an idea. So to answer your question, who has asked online, for time being, the distance between the source and drain is called a channel. That is what the channel formation you have learned in BTech first year itself, man. Correct? Correct? No. So that is what we are calling here as a channel length. And that channel length is actually mapped to technology node. That channel length is mapped to what? Technology node. So whenever someone asks, they ask this way only. Yeah, which technology node you are working? They will ask this way. Okay. So now you got this technology node term. The one who has asked the question, did I answer your question?
Yes, sir. Clear, sir. Thank you.
Okay. So now, as we were
Can I
discussing,
can I ask
uh,
can I ask a question, please?
there are a lot of
Can you
attenuation.
hear me?
No, I can't hear you. Now, can you please again repeat?
Can you hear me right now?
You are not actually clearly audible here.
Can you hear me right? Can you hear me now?
Can you guys help me because I am growing old actually. Can you please type the question? Yeah, I am good into that, man. Can you please type your query because actually what is happening? They have connected the audio to this projector, so maybe. And yeah, don't worry if I take online classes sometime, you will not face this issue because I take from my room, which is having complete setup. Can you please ask the question here itself in the chat window if you are not able to reach out to us? I will take this question offline. Will that be fine? Can we move forward slowly? Because I know you guys are feeling a little bored. We need to come to interesting part. Okay. So now, as I was discussing for the Harish told me he wanted that chip. Okay. And I am telling that Harish, now we have moved to latest technology node. When you were talking that time, this was sent to you privately. I don't know. I will see it later. Private message. Okay. So Harish has told me to make that chip in 2018, but the things have changed drastically, right? Now the technology is shrink, right? So earlier, if I could have actually converted whole logic into transistor form, maybe I would have needed that time some 1,000 transistors in a small area, let's say. In the same area, I can actually use some 5,000 transistors nowadays. That has happened, right? That means his logic can be made in 1/5 of that area. Apparently, this is what the calculation is. Correct, no? And that is what the Moore's law also say, no? Every 18 months, so calculate from 4 years, it is happening the same thing, right? So we are following Moore's law. You got till here at least? Yes. Pakka? So now, whatever logic I have written, that logic now need to be converted to latest technology node, no? Then only I can draw, right? Otherwise, whatever AND gate he has written, so AND gate which was actually manufactured at the time of 2018 and 2022, both will change, right? The size will change, obviously. Compactness will come. Yes or no? Any doubt on that part? But my question is, logic will change. लॉजिक नेवर चेंज यार आर्यभट्टा सोल्ड के समय में जीरो आया ना so if any number multiplied to zero was zero that time also and now also it never change logic no don't change I mean logic will never change okay but the way you implement the logic will change. Correct? So till here, your code, whatever is written, it is independent of technology. Correct? Can I say that? Can I say that? The one who have written this code, front-end design engineers, they are known as RTL design engineers also. What they are known as? RTL design engineers. RTL means register transfer level. Register transfer level. Why we called it as a register transfer level? Because the logic that is written, it can be actually implemented with the help of bigger logic. For example, you want to make some kind of logic, something like this. Okay, let's say you want to make some logic, something like this. Something like this. Correct? What is this? It's a half adder. So either we write with the help of AND gate and XOR gate, or else directly half adder. So RTL guy, why he need to go to that miniature level and write a big code? He can write the half adder directly, no? If I want to make a full adder, I can use two half adder and one OR gate, my task will be done, right? Why I need to write a big logic? You got it? That is what the reusability of logic is. So the code what he is writing is a register level, okay? But now the things will change. So now one step will add from here, okay? That step is called as synthesis. What it is called? Synthesis. Yeah, when we started the session, 9:45, right? Hmm. Just remind me at 11:40 or something. Mind a bit. Synthesis. So what we do in synthesis? What we do in synthesis? See, RTL code will be there, right? The RTL code that was written by someone. That code now need to be converted into. See, at the end of the day, what is the building block of any chip? Transistors only, no? So if I convert that into gate format, AND gate, OR gate, NOT gate, so easily we can make it, right? Because AND gate, how to make with transistor, we can do that. And even those AND gate, OR gate, NOT gate are already available, made by someone. I will tell you who are those guys. But yeah, you got it. So if I convert this RTL to gate level, my task will be done for that particular technology node. But see, the conversion will happen to gate level. I'm telling you one idea of synthesis. This RTL code will be converted into gate level, and this gate level should be mapped with some technology, with required technology. So for example, let's say he want to make it in 22 nanometer. So 22 nanometer, it will map it. Okay. So whatever transistors you are using, the gate length will be approximately 22 nanometer. Clear enough? Any doubt? So each time, let's say today he is telling 22 nanometer, tomorrow he is telling that I want in 18 nanometer. So reusability of RTL can be done, right? Because that is independent of technology. But once you are done with your synthesis, so synthesis will convert into gate level, then it will map with some technology node, and after that it will do some kind of optimization. Optimization with respect to what? PPA. What is this PPA? Power, performance, and area. Power, performance, and area. And this is the build. This is the one which decides the cost of a chip. A cost of a chip is always controlled by these three factors. Okay? How much power dissipation is there, how is the performance, what is the size. Even if you go to buy a mobile, same thing you see, no? How big is the mobile? So then you say I will go with some slim and some lightweighted or something like that. But even though it should be slim and lightweighted, it should be fast. Then you go for processor. Then you will say that okay, MediaTek and Qualcomm only two. In that I will go with Qualcomm if I have budget. If I have low budget, I will go for MediaTek, because see, these two are only big giant in processor designing. You might be knowing. So MediaTek, they makes this Diamond City is the latest one. We made it in 2019 itself. When they made first time Diamond City, I was part of that project, luckily. And when they made Triple Eight, I was part of. You see, I was lucky enough for both the big revolutions actually. So even Samsung also, Epsilon you are saying, right, Exynos, but they are stopping that. You know that Indian market they are stopping now. They are like not a big thing into processor designing. The big giant is Qualcomm and MediaTek only. MediaTek has its own market, low budget mobile, 12 to 15,000. They are very good. But Snapdragon, if you come, More than 35,000 if you go, or 30,000 best mobile, obviously you will see processor Snapdragon 888. I want that. Simple. You got my point? So in that, what you will see? Hey, after playing PUBG for 4 hours, is it heating or not? Correct? No, this new generation sees that, right? What we used to see that time after playing songs for 2 hours, how is battery? So you will check battery quality, you will check the power dissipation, all those things, right? And even the size. So that is what the PPA is, right? Power performance. So this decides the cost of the chip. Hey, can you please all mute yourself for time being? Can you please all mute yourself for time being? Please, I'm adding. You don't mute. Otherwise, I do only one thing. Cancel. That's it. Done. Anyways, so is it clear till here? Any doubt? Okay. So synthesis is that step. So now you may think, hey, where is PD engineer? Till now, he did not mention anything about PD, physical design. Am I going to do synthesis as a PD engineer, or am I going to write the code, or where I am into picture? Yeah. After this, you will come into picture. Actually, yeah, I will talk about that. Till here, any doubt? So after this, you'll get the synthesized code. We call it as a synthesized netlist. RTL code, we call it as a RTL netlist. Netlist is nothing but the list of the net. No, name itself says the list of interconnections. Actually, it will not be having only net. The connections, how is it connected to B, what is the net, and all those logical connectivity will be there into that. So synthesized netlist and RTL netlist. If I ask you what is difference between RTL netlist and synthesized netlist, you will be able to at least give few differences, right? This guy is technology independent. This guy is technology dependent. Correct? This is register level. This is a gate level. RTL netlist is never optimized with respect to power, timing, and area, right? But our synthesized netlist is optimized. You may think how what kind of optimization we can do. See, I will give you one small example. Yeah. See, you can do this kind of optimization, right? What it is? Isn't it the same thing? So in one case, it will require this much area, some net length, something like that. Here you require only this much area, no? So you are able to save little bit of area, and even you are able to say how many transistors you can check. Even you are able to save power also, because for both power is needed. So you saved little bit of PPA, no? Huh? Now this lady is saying, "What man? You saved one gate only, and you are making like as if you have done big task." You are thinking about one gate, but in your design, billions and billions will be there, no? So if you go for Boolean optimization of billions of gates, see how much millions of dollars you are saving. Seriously, chip designing actually depends on all these things. Is it clear till here? A small actually optimization can save millions of money. That's why when you save power or something, you will be awarded like anything. There will be articles on your name. Oh, you have done a great job, like that. You may think I did nothing, but you have done wonders, because at the end of the day, your company has saved millions of money like that. Is it clear till here? Can I move forward from here? Because from here we are coming into picture. You want a break? If you feel exhausted, we can have a break of some 5 minutes if you want. You guys want it? Online attendees, I'm asking to you guys also, yeah. Don't feel
Yes, sir.
like cornered. No one is asking to you. I'm asking to you guys also. You want a break, or we will continue with this?
We'll take 5 minutes break.
5 minute break, little. Okay, okay. We'll take a 5 minute break, then we'll start. 11 o'clock, sharp 11 o'clock, we'll start it. Okay.
Thank you.
Yeah, can we resume? Fine. So we have discussed till here, till synthesis it is done, right? So once your synthesis is done, what they do, that same netlist now need to be converted into chip format, right? So we will be coming into picture. So netlist is what I will tell you. Netlist will be having the logic written, okay, and that is converted into gate level, right? That means now at least you will have an idea that how many gates are in your design, correct? No. So for that, what happens? See, everything now needs EDA requirement. What is EDA?
Electronic device automation.
Electronic design and automation. That means now tools will come into picture, in which you will be designing or doing something. Okay. So we as a VLSI engineer, we can't go away from these things, right? We need to use tool because everything we need to work with the machine only, no? So machine will be working because billions of transistor. Can you take billions of transistor and place it by your hand? Is it possible? No, right? So for that you need some kind of automated thing, some kind of things, right? So for that tool will come into picture. Okay, so EDA will now come into picture. That will solve that. That will actually make the bridge from there to final chip. Okay, so now there are two different vendors in the industry. They are very famous. There are a lot of EDA companies. I will discuss about that in 5-10 minutes. I'll give you an idea. But two are very famous. That is like Synopsys and Cadence. Okay. Okay, so two companies which are very famous for providing tools on which we can work. So in VLSI Go they will be following the synopsis flow. So I will talk about synopsis only, and even most of the industry they follow the synopsis flow. Okay, and they depends on project. See, cadence tool are little less expensive. Okay, but when it comes to PPA they don't give that kind of convergence. Okay, synopsis tools are expensive, but at the time of PPA they will give good convergence. So it depends on business model of any company. For example, I am not pointing to a XYZ company. So let's say XYZ company, their budget is they want to manufacture a chip in 15,000 only. That means, I mean, not 15,000. At the end, when it will be going to mobile, that mobile should be not more than 15,000. You can figure out no which way they will go. I'm just giving, I mean, I don't want to coin a term actually. Is it clear? So in VLSI Guru, they are teaching synopsis. Reason is most of the industry, most of the big giant, they have moved to synopsis flow. Like you told, Intel, no, completely works on synopsis flow. Okay, so we'll discuss that. So what we do in this tool, can we move forward now? I'll give you an idea now from here. So what we do, since your synthesis is done, you have a netlist. Synthesized netlist is there. Okay. Dot vg. I'm telling dot vg. Vg means G means get level. Dot v means it's same Verilog file converted into get level now. Is it clear? Now if I load this to the tool, let's say I'm using Synopsys, and here the tool for your physical design is ICC2. ICC. Okay, not cricket or ICC. It's like integrated circuit compiler. IC compiler. Okay, and there is two. Reason is there was one tool called ICC. The enhanced version is ICC2. Okay, there is one more advancement actually that is called FC Fusion compiler. I will not talk about that. So we are working ICC2 here. Synopsys ICC2. So in this ICC2 you will be giving your gate level netlist. Okay, apart from that other files will be needed because see you would have written, so code will be there in AND gate that is mapped to 28 nanometer, let's say. So if it is mapped to 28 nanometer, at the end of the day, if my AND gate is coming into picture, let's say this is the AND gate, then how is internal diagram, how is the layout, what will be the width of that particular layout and all those need to be known, right? So for that I need a file where the rule will be written, TF technology file, correct? Is it clear? Now the AND gate also will be in different variant. Like one AND gate is able to drive two cells. Let's say one AND gate is there which is able to drive 4x, 2x. Like that drive strength will be there. So the size will change. Now the size is changing, and then how it will sit into the design, small, big, and all. For that I need some file now, which where the dimension will be mentioned. For that I need left file. Okay, so you will be understanding all these files actually in details. Don't worry about that. Similarly, how fast is this? If I give 0 1, If 0 I'm giving, how fast it is going from 0 to 1, how much time it is taking, all those timing related information, it will be mentioned in some file called as .lib file, library file. Okay, is it clear? I mean, I understand that you don't get 100% here, but 20-30% is fine for me. At least what I'm telling, there will be a tool. If you give proper setup to that tool in a nutshell, then after that you can go through the full flow. Okay? So now assume that I have given the net list. Now in that net list, you have the area for all these and get and all. Correct? If area is given, then what will be the chip size? You can estimate that. You can estimate at least. See, for example, I will give you some example, simple example. Let's say Haris is there. Okay, Haris, how many brothers and sisters? One brother, sister. Okay, let's anyone who is having more than one brother, one sister, please. You, please. How many brothers, sister? Okay, I will take my example. I have two brothers, two sisters. Okay, so we are five. Okay, don't start judging my parents. Okay. Okay. So now I have two brothers, two sisters. That means we are three actually, three brothers actually. Okay. So total five, Z plus two, and then two here. Total five. Now I'm telling that I require a room with some. Let's say I'm telling that 100 square feet is fine for me. My elder brother is saying I need 125. My younger brother is saying, hey, see, I need all this luxury item, everything. Okay. So the younger one, big demand. Okay. My sisters will be like, sisters are generally like, I don't want big room here, but cute room I want. Okay. So they are saying 75 is fine for us. So with this, I can decide the area. Yeah, don't be selfish. Include your parents also. Okay. So they require 150. So total area, how much is needed? I can calculate that. In that I can, if I take that much area, I can make a house, it will be fine for me. Will it will it you need little bit more area, no? Where you will walk, man? With this area you will only make room, entrance, walking, other things are also needed in that, right? Correct. So at least I got an idea, no? Area estimation will be this value is x plus delta s. If I take, I will be able to do the things, right? Yes or no? Pakka? So now you have a net list. In that net list, let's say 1 million gates are there. And each gate is taking 1 micrometer square. So 1 million into 1 micrometer square is the area, correct? But when I'm taking this AND gate or gate, there will be some connectivity, something like that. Correct? So for that, we need to allocate some more area. So that overall area, whatever is coming, let's say that is cell area. We call it as a standard cell, AND gate or gate, something like that. Cell area plus some extra area. Plus some extra area. Why this extra area is needed? I will talk about that. If I decide this extra area and this total standard cell area, I can tell that this will be the dimension of my chip. Yes or no? Yes or no? Now I found the dimension of my chip. Let's say that roughly I am telling that the dimension is some this much unit. I'm not talking anything unit square, something like that. Clear? 100 plus 100 हो रहा है ना, ठीक है. So I am telling that this is my complete area. Okay. Now my task will start. Who I am? I'm a PD engineer. I'm a PD engineer. Now my task is going to start. Can we discuss that now clearly? It will take half an hour. And you will understand what we do. Can we move forward? Okay. Okay. Now what we are going to do? We have given. So let's say we are working on a design of processor. We are doing a processor design. Processors, you know, right?
So
What it does?
that's just an estimation, or once we start designing, we need more. We cannot
We'll
tell
discuss that. We'll discuss that, man. It need more. We'll take area. If don't need, we'll cut the area, because anyways we are doing rough things right now. Trial and error. So we are going to do processor designing. Mobile processor, madam. What we do with mobile? Photo, video, audio, internet, games, and sometime calling also, right? Sometime if time is left, we do calling also, right? Which was the main feature when it was developed. Now that is the last one. Correct, no? How many of you now also talk for 2 hours continuously? No one does, right? Correct, no? So main feature of mobile was calling. Now it is like the last feature. First is Insta, Reels, huh? Correct, no? Then we'll go to Facebook. Then maybe some crazy guys will be their games, YouTube, correct? Then at the end something like calling or some education purpose things and all, right? Quora, you know, that is the last thing. You know Quora? Don't know me. Okay. So till here, any doubt? So we are going to make the processor. So in the processor, the feature is what? Some camera, something like audio, video, all those things, right? So what we are going to do, there will be some portion of your design which will be doing audio activity. There will be some portion of the design which will be doing video activity. There will be some portion of the design which will be controlling the camera activity. There will be some portion of design which will be controlling your calling methodology, that is network. Have you ever heard when you go to mobile shop and you tell that sir call करने पे आवाज नहीं आ रहा है, I'm not getting the signal. He will be like भैया network IC गया, network IC is gone. So you think that what is this network IC? Correct? No. So that is what it control your calling features, NICs, network ICs, right? So if you see network IC is there, audio IC is there, video IC and camera, all these integrated circuit. It is inside something, not motherboard. I'll tell you what it is. You remember what definition you told about physical? SOC. So this is called as not silicon, system on chip. And this individual is called as ASIC. Application specific integrated circuit. What is this audio control going to do? Only for audio only, right? It is not control the video thing. Got it? So this is also integrated circuit, but it is controlling the feature of audio thing, right? So this will be like ASIC, application specific integrated circuit. But when multiple ASICs are housed on a single wafer, apparently it will be called as SOC. It is what you were telling. So that's why I cut down that time to you, because that was a little high level thing. So processor is a SOC actually, which have billions and billions of transistors. As one, okay. Now I have been allocated this much area. Okay, and I have been told that you have to do a processor designing in that. So I have 4 different kind of ICs need to be drawn into that. I will call them something. I will talk about that. So I'm calling my processor at a full chip. What I'm calling? Full chip. Don't write FC. You write at a full chip. Otherwise, FC means fusion compiler. Full chip. Okay. In that full chip, sorry, there will be some logic. Total logic is 1 million, assume that. Okay, out of 1 million, some 200k logic is for audio, let's say. Okay, some 200 k नहीं होगा यार, some 200 units बोल लो या कुछ और बोल लो, k तो k will be like 220 million बोल दो क्या, but 0.2 हो गया, 200k is 0.2 million. Correct, no? Then is fine. Then I'm correct. So 200k logic. Okay. Similarly, some 225k logic for something like that. The logic will be divided. No, the network one is the complex. So let's say it requires 400k logic, something like that. But overall sum should be nearly 1 million, because that is what apparently it is. Is it clear? Now I need to allocate the area. First thing what I need to do, area allocation. Correct. One rough estimation I got, I need this much unit, 10000, and I'm going to make a square chip. So obviously 100 cross 100 ka area I have got. Yes or no? Now in this 100 cross 100, I need to allocate the highest area to whom? Network wala guy, because that is the complex logic. It will be having what? It will be having a transmitter, receiver, attenuator, filters, because obviously network thing you are doing, no? Power amplifier, all those logics will come there. Correct? No? Yes or no? So for that I need to give more area. Now I need to decide where I need to give that area. Should I give area here, here? Then I will decide where exactly is my power antenna going to feed, or how is the connection interface. So that I will decide at the chip top. I am the one who is more experienced. Let's say I am 10 years experienced guy. Nearly, it will not never be 10. There will be like 20 plus experienced guy who own the top full chip. Okay, I am the youngest. I know till now. The one who own full chip, they will be like 15 years experience minimum. So they will know everything about your design. So let's say antenna is here. Okay, if they know that in future antenna will come and sit somewhere here, then my network IC should be near to that closer connection. If I place my network IC here, the connection will be big, right? How the signal will transmit it, there will be lag, right? That's simple as that. So I will do a partitioning where I will allocate the area. Yeah, partitioning happens in real time also, no? parents will give their land to their kids by partitioning, right? Some area they will give to elders, like that. Same we will do. We'll allocate this network IC this much area, let's say. That is NIC now. Based on the complexity of the design. So based on the complexity, I'm giving audio. Okay, audio, some logic. Now if I place my video logic here, or if I place my video logic here, all these things I need to decide myself, right? Because I'm the more experienced. If I place this video logic here, okay, and here the some song is playing, we are playing some, let's say some Chikni Chameli, and the step is for Katrina Kaif, and in the video it is showing that Hrithik Roshan is dancing on that song. There is a lag, no? Correct, you are getting my point? The synchronization should be proper, right? So obviously I need to put this video logic here, some video control unit, correct? And then some synchronizer logic will come and place into center. So this way I will do the partitioning as a chip top, as a full chip owner. Then I will call this as a block. What we will call? Block. You will be the one, freshers, till 3-4 years, 5 years, 6 years actually, maybe 10 years also, based on complexity, you will be owning a block. As one, so we'll give this block to you. Here in VLSI group also, you are controlling Orca top. That is the block actually. Is it clear? So this block I will give you. You need to design this block now. So first step was partitioning. That I did at the chip top. Now I am telling that Haris, let's say this is your block, Haris block. Let's say I am telling Pushpa this is your block, and I am giving the dimension of this block. Okay, some this is 100, no, some 20 cross some 18. Correct? No, this will fall into that 20 cross 18. Okay, Pushpa, you got it? So now 20 cross 18, I have allocated area for Pushpa. So now how Pushpa will start from here? Can we quickly look into that? Is it clear till here? Any doubt? First step what we did? First step what we did? Hey, partitioning, right? And point I mentioned that done at full chip or chip top. So you got an idea a little bit. See, there will be chip top. Okay, chip top, the full top, like Snapdragon final 888. In that a lot of things will be there, right? So we are dividing those into small blocks, we are calling. Some company will call blocks, some company will call partitions, some company will call them tile. AMD will call tile. They have a flow called tile builder. They call it a tile. In MediaTek we used to call partition. Okay. In some company they will call hard macros also. That also is the thing. Samsung they will call blocks. So different names are there. So blocks, blocks, something blocks, audio block, video block, CPU block, like that. So you will be owning video block. Okay, Pushpa is owning video block. Haris is owning audio block. Okay, let's say you are owning some other block. So like that you will be block owners. Tomorrow if I will come and take meetings, I will ask, tell me the status of your block. So you are the sole owner for that. Is it clear? Is it clear till here? Any doubt? Online attendees, any doubt?
No, sir, all clear, sir.
Okay. Now inside that block, for example, let's say I'm taking an example for Pushpa. Pushpa, I have given you 20 cross 18, correct? So 20 cross 18 block I'm telling. Like the 20 cross 18, I'm telling that this will be your width, this will be height, something like that I told her. Now when she loaded this netlist, because for her I will give separate netlist now. See, I had a complete netlist, top.v. Some Snapdragon top.v. In that all the logic were there, no? 1 million gates were there. But inside that some 200k gates was for Pushpa. That I'm giving, right? Video control unit. So I will partition and take out that module for her. So in this top.v, that partitioning what it does, it will give you 4 different very long. Some vcu.v, some audio.v, something like that. And at the end when you club it, it will be top.v only. Is it clear?
Yes, sir.
Is it clear till here?
Yes, sir.
Any doubt? Pakka? Acha. Now in this what happen, in every block also, you will be making a complete logic for video control unit, okay? You will require AND gate, you will require OR gate, NOT gate, muxes, flop, latches, all those things. Apart from that, there is a possibility you may require memories like SRAM, DRAM, PLL, phase lock loop for clock generators. Big memories, I mean what? You know how memories are made? Internally again AND gate, OR gate, NOT gate will be there. You are getting my point. It is something like that. You want to make a building, okay? In that building, you will be require bricks to make. Bricks are fundamental building block which will make. Now ready-made, let's say ready-made some washroom is coming or ready-made kitchen is coming. So what you will do? You will again make the kitchen or ready-made you can buy. You give me the simple thing. If already ready-made things are there in our market, you can reuse it, no, directly, or you will start making from starting. Hey, you're getting it? So already ready-made things are there. You will just reuse it, or else you will start making again kitchen again. It is already there. You take it and assemble it. That is what happens in India, yaar. It is Mahindra car. What do you think? They manufacture really car here. Parts they will make with the help of some different bigger vendors. Correct? They will go and talk to this guy. Like you might have seen this Tata Harrier, Range Rover platform owner, right? So they will go to bigger giant and they will make these parts. Assembling we will do in India. You have heard this news? Apple has set up their manufacturing unit in Hyderabad. Do you really think they will do manufacturing there? Part will come, we will assemble it. So reusability is happening. Same happens in physical design also. So what I told in this logic, in this block level also, you will have AND gate, OR gate, NOT gate, flop, latches, everything will be there. Apart from that, some hard like SRAM is needed, or DRAM is needed, or PLL is needed. All these are like big entity, big entity. This entity will again made with the help of muxes, flops and everything. Okay. So what happens? There will be some companies which will make this individually. They are called as IP manufacturers. These are IPs only, right? These are intellectual properties, right? SRAM, DRAM is available in the market. I can take it, right? So there will be some company which make IPs. Okay. Or else in, let's say MediaTek is there. In MediaTek itself, there is a team which develops the IP. Macro team is there. They will develop the IP. These are called as IP or macro. Okay. So when you ask what is this macro, most of them will say that macro is nothing but our memories. It is not completely true. See, all memories are macros. That statement is correct. But all macros are memories. This statement is not correct. There are some macros which do some other task also, like PLL. It's a clock generator, right? I mean divider basically, phase lock loop. Inside VCO will be there, where voltage control oscillator will be there. Then you will distribute the clock from there. So it's not a memory, right? Is it clear till here? So macros we can reuse. Now there are companies which will give you macro and you have to use it. They are the bigger blocks, right? Reusability is there. So what we can do? First thing what we will do? See, if you buy a house, you are going to now put the things in this house. Okay. So what you usually do? You will be placing your this bigger things first or smaller things first. You tell me, Pushpa. Why? Yeah. So I asked like if you are going to make, let's say you are going to move into a newly made apartment, okay, and she is going to arrange her room. So this is her room, okay, and in this room she is going to put all these things. You have refrigerator, bed, her this thing, what we say, laptop, and everything is there, right? Gym machine and all everything. Don't look like, but yeah. Correct? All these things are there. You have to place it. What she will do? She will take her bed and she will put it here in the center. She'll put her refrigerator somewhere here. She'll put some gym thing here. Something like this. We'll do this way? No, right? Because routability issue will happen. No, if I put bed in center, where you will walk, man? You are acquiring whole area, right? So what you will usually do? Tell me what you will do. Corners only, no? You put bed somewhere here, refrigerator at some good place so that at least big area you give, right? So bigger things you place first and leftover area you leave it for other things, right? Same goes for macros. We need to place macros near the boundaries. Leftover area we'll keep it for standard cell placement. AND gate, OR gate, NOT gate. Is it clear? So the first stage after partitioning will be for you. You will do first thing called as floor planning. What you will do? Floor planning. So floor planning is the first step of physical design flow. Is it clear till here? Is it clear till? I will conclude it. Don't worry. Floor planning. You can write it. It's very easy to understand. No, the name itself is saying. But that don't goes with Puspa. No, Puspa fire. There is no combination. Correct? No. But here the name makes sense. Floor planning. The name. What it say? There is a floor. I have to plan how to place the things on that floor. Something like that. It is making sense, right? Same thing you will be doing. You will first. I told to Puspa, you need to maintain 20 cross 18. So what she will do in the tool itself? There is a utility. She will actually assign that area. Once you assign the area will be formed. Something like that. Visually, you will be able to see. Like this area is allocated. All this logic will sit at 0, 0 coordinate. Standard cells, macros, everything will be here. Now slowly I will tell that what you do, Pushpa. Now bigger thing can you place first? She will take all the macros, she will start placing somewhere. I mean, I don't know. There are rules to place. It will say the connectivity between the macros, everything she will check and she will place it. Anyways, you are going to learn those things only. I am not going to teach today. After placement of this thing, even she will place the interface connection. There will be interfaces, no pins or ports. That connections she will place. That is done in the floor planning. Okay, so she will do floor planning in such a way that again the main ideas for you will be PPA. You have to control PPA at the end of the day. For example, this guy is like a macro belonging to family A, and this guy is a macro which is belonging to family A again. So there will be always a connection between A and A, right? Communication. Then why you are placing there? If you place there, the more net will be there, no? Net length will be high. If net length will be high, to drive that signal, tool will add more buffers, repeaters, to increase the intensity of that signal. More buffers tool will add. You are spoiling that much area because buffer will take more area. Correct, no? Easy thing will be if I place this macro here itself, less buffering is required, less area is required. If you are adding 20 buffers here, you will add two buffers only. You are able to save area for 8 buffers. Even those buffers require more power, you are saving power also. So this thing you have to do intelligently. So floor planning is the first stage of physical design flow, where first thing you will assign the area. That is what we are doing, area assignment. Okay, and after that we'll place the macros and the ports, interfaces. And one thing should be in my mind, I have to utilize the area very intelligently. That is the main aim of floor planning. Is it clear? Is it clear? Once it is done, I'll go to the next stage. Floor planning I finished in some 2-3 minutes. That will go for at least 2-3 weeks for you guys. I mean, at least some 4 classes over the weekend. So don't worry, you will have like complete things are there in that. I'm just quickly going because it's a demo class. Now next stage is placement. So in placement, what happen? Whatever standard cells will be there, AND gate, OR gate, NOT gate, everything will be placed in the core area, in the center area. But when it is placing, the tool will place because there will be millions and millions of cells. No, you are not going to place with your hand, right? The tool will place. Tool has its own algorithm to place based on again PPA requirement. The internal algorithm will be such a way it will be optimizing with respect to power, timing, and area. Like when tool is placing these cells, tool will say that some kind of cells are there. They have a connectivity with this port, so it will move and place it near to this guy. If this is having connectivity somewhere here, it will move and place this guy. So this kind of placement it will do. So placement is the second stage where the standard cells will be placed in the core area. Is it clear? Is it clear? So once the placement is done, next stage is called as CTS, clock tree synthesis. This is a very, very important stage actually in physical design flow. Clock tree synthesis. Why it is needed? Because see, you in starting only I told no idea and specification will be there. Your chip will be always working for some standard bandwidth, right? For example, if I'm telling Bluetooth, that means in 2.4 gigahertz it should work, right? If I go above that, below that, and all, you are actually not meeting to that frequency. There is a frequency range for everything. Is it clear? That means if I have a flop here, let's say one flop here, some data is there, one data is launched here and data is going till here. So whole launching and capturing should be happening within that frequency range. Yes or no? See, to make it easy, I will make it 2 gigahertz. 2 gigahertz means what? 1 nanosecond? 1 gigahertz. That means less than that. That is 0.5 nanosecond. Correct, no? So in zero point 0.5 nanosecond, you need to do completely launching and capturing. Your data should be launched and captured. If you are not able to do that, two things will happen. Either performance failure will happen or else functionality failure can also happen. Why? What is your what data you are launching? You are launching 0 and 1. So whether it is 0 or 1, it should be very clear, right? Clear? If I am launching 1 and if you are not making the data stable for some amount of time with respect to your flop, other data is launched at the same time. You will be confused, right? You will be confused, right? Same thing, the device also will be confused, and in that data will be lost whether it is 1 or 0, ambiguity will come. That is again a functionality failure or a performance failure. It depends what kind of failure you are doing. Is it clear? How it can be functionality failure? Very simple. For example, a hard disk is here. In hard disk there is a reset signal. In this reset signal, currently the value is stored 0, and by mistake this 0 become 1. Your hard disk, what is the functionality of hard disk? Store the data, but what will happen? Data will be erased. Functionality change, no? So this, if these things are not maintained properly, your things will be gone. Okay, so that's why clock tree synthesis is very important for physical design engineer, where you will be propagating the clock to each and every sequential element, because sequential element for functioning what they want. What is food for them? Clock. No, you are hungry, right? Me too. So for flops also, food is clock. They also want to eat, so I have to give them the clock, but not like quickly I will give the clock to them. It will create issues. Correct? No. If I start distributing food here and quickly I give to everyone, and it is very spicy, all will ask water quickly, right? Will I be able to serve a single person? No, right? Similarly, if you have 1 million of flops in your design, every flop will start switching at the same time. Power dissipation will be very high, right? You will die. Your chip will die. It will burn. Boom. Clear? So we need to maintain certain kind of lag in that. Skewing, you say that. Clock skew. So we do that in CTS. Once these things are done, next stage is called as routing, in which we will propagate our clock net. We propagate our nets, real correction, and we will create that. So at the end of the day, what will happen? Quickly, I will go. I am going to close this topic now. I'm done actually. See, because if you start talking these things in demo class, other things will be left over, which is important. So we'll close it. See, these are the nets. Sorry, these are the pins, and we have placed the macros. Once we are done with the macro placement, this we did in floor planning. After that, what we did, we placed some this standard cell. Correct? Once the standard cells are placed, after that, what we did, there will be some clock net. I started propagating those clock net to all the sequential element, only to the flops. Okay? And we will maintain some kind of skew. We will not make everything at 0. What is this skew? The time in which clock is reaching to this flop and this flop, that difference is called as skew. So if it is reaching at, let's say, x and it is reaching equal to y, if x equal to y, then it is 0 skew. I will maintain some kind of skew where maybe x is greater than y or x is less than y. That little bit I will maintain. With that I will be able to control. Otherwise, you know what will happen, right? Is it clear? Okay. So now after that, routing means signal net. Now this was the clock net, right? In routing we do signal net connections will be done. Signal net will be connected like this. Okay. In floor planning itself, there is a part called as power planning, where we will be providing power rails. We will create the power mesh and power rails. So that is done as a part of floor planning itself. That's why I didn't teach it. I mean, I didn't write it actually. Once your routing is completed, it will go to sign off. In sign off, till routing, we will be doing the task. We are called as PD engineers. We will be doing. And what we will make, I will tell you. Till here, everything we will do as a PD engineer. As a PD engineer, we will do this thing. This flow is called as PNR. 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 PNR means placement and route. So they have not mentioned floor planning because in automation only placement and routing can be automated, right? So generally we do from floor planning till the routing, but they are calling it as, I mean, it's famous PNR. Even it is also famous as APR, automatic placement route. APR, automatic placement and route. There are different jargons to mention that, but this is what the PD flow is. Floor planning, power planning, placement, CTS, routing. Done. After that, we'll go for sign off. Reason is our main aim was PPA, right? Power, performance, and area. So there will be different teams which will tell that whether you are meeting the power requirement or not. So there will be a team which will be working on power analysis, and they will be using different tools. For example, Redhoff is a tool. They will use this kind of tools. There will be a tool which will be doing timing analysis called as STA, static timing analysis. There will be a tool which will be seeing that whether your physical requirement is meeting or not. If the width of the net should be this much, whether you are maintaining that or not. So those are called as PV team, physical verification team. Is it clear till here? So once all these things are done, and if this sign off is saying that whatever you did is correct only, then finally there is a phase where we will be doing the dumping of data, and that data will go to foundries. What data we dump? We call it as a GDS. What we will call? GDS. I will tell you what is this GDS quickly, and then we will done. I mean, almost we are done. So at the end, what we are making as a PD engineer? GDS file. What is this GDS file? As he started his discussion, if you remember, he was telling, sir, civil engineer, something he was telling, I stopped him. See, it is same as good as, see, when we want to make a building, civil engineers will be the one who will be making the building, right? Correct, no? But before that, we go for the architecture, no? What will be blueprint, basically. So GDS is nothing but your blueprint of your design, layout of your design, where your exact design will be there, and how is the internal connection, how is the gate connection, how is the contact, all those things will be there. And this goes to the foundry, and the foundries will manufacture the chip, and it will come into market. Is it clear? Is it clear? So I'll just quickly tell one thing. From here till this GDS, from RTL to GDS, this flow is completely called as ASIC flow. If anywhere they ask ASIC flow, you can tell them. Even it is also, you can call it in a VLSI flow if you explain in a beautiful manner. Like this is called as front end. Okay, front end, where we are doing mostly the writing of the codes and all, right? Synthesis is a horizon. Some company they will be calling it as a front end, and some company it is a part of back end. When I was working in MediaTek, my synthesis team used to sit in Singapore. They were never interacting with us, and so that time we were saying that they are front end guys. When I started working in QC, I was sitting with them, next to them. They are in our team. We calling them back end. So different things are there. Depends on which company you are working, how they are. If they are a part of back end under your manager, you'll call them back end team. If they are in other manager who is in front end, we'll call them. So it's the horizon actually. Okay. So now from here to here, definitely we call it as a back end. Back end. Is it clear? Pakka? So as a PD engineer, you are not going to actually manufacture the chip. You are going to give the blueprint. That is what I call it. It is a layout, GDS, graphical data stream file. We call it as a GDS2. There will be two symbol there. That is famous in actually VLSI industry. They will call it as a GDS2. Actually, it is not a GDS2. It is GDSII, graphical data stream for information interchange. But they call GDS2. GDS2 तो famous हो गया अभी GDS2 करके. ठीक है? Quickly एक बार देख लें. Quickly some 2-3 minutes. Puspa, you can have water. Don't faint, okay? तुम्हारा चेहरा देख के लग रहा अभी गिरोगी तुम. You guys didn't have breakfast or what? I did not have because I worked till late night. I think 3 o'clock morning I slept. Then I woke up at 6 o'clock. So I have to quickly come to you guys, right? So I didn't have. Yeah, can we talk now quickly? So we started from the idea, correct, Harris? Then we slowly move. We did our front end designing. So they will be doing the front end designing. The code will be, the language they will be using is HVL. Now I am summarizing. If you want quickly, you can write it. I will quickly summarize it. They will be using HDL for writing, hardware description language. Example is Verilog, VSDL, very high speed hardware description language, system Verilog. Okay, then those code need to be verified, right, whether that is correct or not, in the front end side only. Okay, so they will be using some language, some methodology. For example, system Verilog I told, right? Verilog also can be used for writing test benches. Okay, other methodology are like UVM, universal verification machine, OVM, open verification machine. These all things are taught here. Actually, Srinivas sir will be teaching. He is the one who is owning front end part. He teach front end here. Okay. Now, once that is done, the same code will be going through a process of synthesis. Now, from here, tool will be coming into picture. So, for synthesis also, there will be tools. So, synopsis, I am writing it so that you will have an idea for doing some kind of Google or something. When you go from here, at least some take home should be there. No? You learn from me. You will tell that, yeah, I taught something at least. So, synthesis, there is a tool called design compiler. It is from synopsis. So I am talking about synopsis only. From cadence it is genus. I will not talk about that. But yes, design compiler. So in this tool, when I will give RTL code along with that some constraints like this much frequency you need to meet or something like that, tool will do its optimization because launching and capturing it need to do within that frequency, right? So to meet that, it will reduce the net length or something like that. It will do, correct? So that is done in the design compiler in synthesis stage. So it will convert the RTL code into gate level netlist. After that, it will try to map with particular technology, and then it will optimize with respect to power performance. I mean PPA basically, power timing and area, power performance and area. Clear enough? Once that is done, at the chip top, I will be there. The person who are more experienced, 10-year, 15-year guys, they will do partitioning. Then they will allocate the area based on complexity of your module. So I told block owners will be there, like Puspa, Harish. I made you block owners. You are handling one single block. So in VLSI group also you will be handling one block or cut up. It's a good design actually. It is having some 50 plus macros I think, and some 0.5 million gates. So it's good design. Okay design. Okay. So that design you will be handling. So once partitioning will be done from chip top side. Once that is done, you will be starting floor plan. So the backend starts from partitioning itself. But since you guys will be block owner, you will be doing from floor planning. In floor planning, you will be first allocating the area because I have assigned area for you guys. Either I will directly give you the area. There is a way to give. That is called a def file. I can directly give you def file. When you load this file, actual area will come in front of your screen. But there is a way in which if you give the dimension, it will create the area. That is the tools feature. Is it clear? So you will be creating that area. Once that area is created, after that pin placement, pins you will be placing. Once that is done, macro you will be placing. Okay. Once that is done, your flow planning is done. You will be creating power VDD VSS connections. That is done in the power plan. Once that part is done, you will go for the placement of standard cells as I have talked. That is a placement stage. And once that is done, you will propagate the clock to each and every sequential element in a stage called as clock tree synthesis. Okay? After that, your routing will be done where actual physical connections will be created. Okay? And then you will go for the sign off, in which you do power analysis, STN. So for this, so what you will be learning in PD? Only the still routing. Okay. But now, since power, timing, and this PV is also important to understand, they will teach you theoretically synthesis also here. I used to teach, so they will also teach you. Okay. And STL should be taught to you in a good manner actually. Reason is timing. If you don't know, you don't know anything about the design. So STA also will be taught. And even you will be doing a sign off like in prime time. There is a tool called PT, prime time. So for synthesis design compiler, for implementation of PNR, you have Synopsys ICC2, and for sign off for Redhawk, that means for power it is Redhawk, for STA it is prime time. PV we don't use it, but they have a IC validator, but we don't have setup for that. So for this separate course will be there, but I teach everything in one go, as simple as that. When I teach, so they are also following the same thing. So every trainer has their own way of teaching. So yeah, it's the way. I am done with my physical design part till now. Okay. You have any query with respect to technical aspects? I know. I mean, I understand it's a heavy dose for today. I can understand that thing, but it's okay. I mean, you can't escape from this course. You have to by Google Group learn it, right? Any doubt, online attendees? Okay. Any doubt?
Sir, a small doubt
Yeah. Please go ahead.
regarding that placement. In that placement thing, what the component or what the parameter we used to place on that, sir?
See, in placement stage, that's what I was coming to that part only. Okay, can we discuss? I mean, I will take your question. I need to demonstrate a small thing. Then you come back to again the same question. Your question will be solved in that only. See, I'm going to delete it. It's fine, right? Okay. See, I told in floor planning most of the things you will be doing manually. Placement of the macros and all everything. Visual manual interventions will be more. You'll be using your brain, you will check the connectivity, you will place it. But after that, most of the things are automated. That means tools, commands are there. So you need to learn the tool. That's why you are here. Those tool you need to learn, like ICC2. So in that commands will be there because the machine will work on the command. So I will run one command, it will do the task. For example, I want to do placement. I will run a command called place underscore opt, place opt. That command I run. It will do placement and optimization. Optimization with respect to power, timing, and area. Now in that, how much power it need to optimize, how much area, how much timing, that all settings I need to give with the app options and all, right? So that is what we do, and then tool will be doing that kind of optimization. These are the parameters which will control. Similarly, in CTS, clock tree synthesis, it will propagate the clock. Now, one flop is very near to the clock port, other flop is very far. How many buffers need to be added? If I give the constraint like this 200 picosecond you need to maintain till there, the tool will add that much buffer only, no? So all these app option settings I need to develop. So for that, you need to know language. You can't escape from that. We need to know programming skills also, but not to that high level. You should know one program one of the programming skill or scripting skill. TCL, if you know, it is enough. TCL, tool command language. You can learn it. You can learn from tutorial point out. That is what the next part I was going. I just I mean saved 15 minutes that you lost in starting 15 minutes that I saved now. I am going to deliver that 15 minutes that you lost. That will be the best part for you. So what is prerequisites? For example, let's say you want to be PD engineer. Then what are the things you should be knowing and why you should be PD engineer? Why not you should go for front end or any other thing? See, I highly recommend. Still, you have second thought. You can go for front end also. See, who should go for front end and who should go for PD? Okay, this you need to understand. I'll quickly summarize this in 10 minutes. See, those who are good with, very good with their algorithm, very good with their programming skills, because everyone already done with C language or something. C is compulsory for you guys, right? How good you are in C, you remember those things. So when I say how good, don't start saying that sir I can write make star printing and all, Tower of Hanoi I will be able to make that thing and all. Don't tell those things. When I say is this any programming language, you should be very good in two things. One is looping concept, you should be good. Second is file handling, that is very important, any language. So if you are good with all those things, and apart from that, if you have good knowledge of digital electronics, when I say good knowledge, a very good knowledge, like Maurice Mono should be here. Okay, upper part of your cerebral actually. You got it right. If everything is set, you are good in digital electronics, you are good with algorithm development, and you are good in programming, go for front end. Okay, if you are good in, I mean, circuit analysis, where you are able to understand like how is the current flow, how is actually BJT going to trigger, how is MOSFET going to trigger, how the drain and source is going to travel. I mean, little bit of circuit knowledge, where you like seeing the visualization. See, why people get bored from coding, whatever code you are writing, do you see really it is happening in front of your eyes? See, if I say that I develop that app for Uber, anyone will not be fascinated, right? And if I tell you that whatever calling feature you are doing now, this is transmitting data from here to there, right? That feature I have developed. I am the one who owned that. Okay, even in iPhone 14 Pro also. You'll be fascinated, no? Yeah, that feature is visible. If I talk, you will go see. That is real time. I'm seeing in front of me only, right? So that kind of visualization, if you have, you can go for backend. First thing. So this will help you understanding, should I go for backend, should I go for front end? Now coming to second part. What is prerequisites? That means what I need to learn before entering. See, if you want to go in front end, you want to go in back, apparently you are coming to VLSI only, right? Apparently you are coming to VLSI family only, right? So you need to be having good understanding of digital electronics for sure. When I say good understanding, don't go and start learning FSM. Not to that high level. At least combinational logic, everything you should be knowing. AND gate, OR gate, NOT gate, muxes, those things you should be knowing how it works. Then coming to sequential, at least flip flop, how it works, or register, I mean, same thing, right? And latches, what is difference between flop and latches? All those basic things at least you should be doing in digital electronics. Okay. Apart from that, you MOSFET and BJT, if you work, I mean, how a MOSFET work, how they, you can actually follow the NPTEL videos for these things. I always highly recommend this. Everywhere I say the same thing. You can follow NPTEL lectures actually for these things. Okay, MOSFET, BJT, CMOS, you can learn from there. What the hell? I'm getting call from my own number. Is it possible? Anyway, so this you got it right. MOSFET, BJT, CMOS. Clear enough? This thing you can learn. Not to a very high level. See, what I'm telling you, understand this thing. What is necessary, that only you learn. Like MOSFET, like you can go to NPTEL lecture. I don't remember the name of the professor there. You can just see like how a MOSFET work, how the source and drain is, how is channel length form, how is like current, like simple thing, not to very high level. Then apart from this, BJT, how it works, like NPN, NPN transistor, PNP transistor, how it works, what is this PEN, and little bit basics of semiconductor, basically what I meant to say. Clear enough? Then if you are really interested, try to understand the what is happening currently in the market, like little future of VLSI or little bit explore. That will give you interest. That's the reason I'm saying. What is this augmented reality? What is this VR? what is FinFET, that we are talking, right? What is this technology node? This you can Google on YouTube and get it, no? Aram se. So if you this thing, if you learn, this will motivate you, no? Like, yeah, I want to do something. Apart from this, you will be working on the tool, and that tool will be always working in an environment, Unix environment. Okay, so you need to learn that. Some command like ls minus lrt pwd, how it works. I mean, directly in Windows, if you work same way, you should be like very good in that. This anyways, here they will teach in everything in basics, I guess. They teach this. Apart from this, what I want from my student when I teach them, I want they should be knowing basics of TCL, and advanced thing I teach actually. Same should be for other trainers also. They will also love if you know TCL, and you can learn it. Any programming language, any scripting language, you don't need any mentor, any trainer, anyone to teach you. Everything is open source, right? You can learn it. You can learn it yourself. Okay. So this is what I have. For more things, you can directly reach out to me. That's it. I hope I covered those 15-minute loss in 5-10 minutes. Fine. I'm a bania man. I only go for profit. Is it clear till here? Any doubt? Any doubt anyone having? I will sign off. Just quickly tell me. Otherwise, I will close this session. Yeah, please go ahead.
Can I ask you a question, please? Can you hear me?
Your voice is breaking actually. Can you go ahead again?
Can you hear me?
Yeah, I can hear you.
I have two questions. One of first question is that uh, which technology will be used in the I think in the two sessions, and also there will be any lab sessions in the course. Which technology node will be used, and you give to us a project, I think, right?
Oh, okay. So here the technology node that is being used is 28 nanometer slash 32 nanometer. When I say slash, that means both the libraries are same actually. So you will be working on a project that is like a block level implementation with a good actually complexity. It has 50 macros, some 50K cells, and I think some 200 plus I think 237 ports are there. And it is multi-voltage design, because I mean it's not in one voltage, you have multi-voltage design. So overall it's a good project. And the technology node, again I will be very clear, they will be claiming it 28 nm, but the library is from both the 28 nm and 32 nm. It's the same library they are using. Okay.
Okay, I understand. So the second question is, what is the time duration of the course? Can you say?
What is the calculation or duration? What I missed that.
Course duration. Course duration. 2 months, 3 months, 6 months.
Okay, 1 minute. So one thing, again, I'll cut down this. This question, can anyone just remind me that? So what is going to happen? I will only answer the technical question. When I told in starting only, the first question was my question. Now I will call someone. I'm going to call him. He is from VLSI group. He will take your managerial question. I'm the one who will take the technical question. Okay? I'm pure techie man. So they will tell the
Okay.
cost, duration,
Okay.
cost of fees, whatever they will tell. I will only tell you the technical thing. Just give me 2 minutes. I will call this guy, and then I will come here. I will be there for 10-15 minutes. Okay.
So you teach, and lab sessions. Also, you give the lab sessions, or another trainer give the lab sessions?
Yeah, I
Sorry,
missed
can you
you
hear me?
actually. Any question I missed?
Yeah, he was asking something.
Yeah. Please go ahead. Please go ahead. I'm back.
Okay, I think in the teaching sessions, you give teaching sessions, and lab sessions. Will you give lab sessions also?
Yeah,
And
okay. So
how will
basically, yeah, this is
and
the thing I will take this.
and
See, there will be pool of mentors and pool of trainers. What are trainers? What are mentors? I'll tell you. Trainers are the one who are actually experienced person from industry. Mostly they will be close to some
mhm, mhm,
10-year experience. More than that, also there are trainers. There are some 5-6 trainers here actually. Okay, so they will be
uh-huh.
delivering the sessions over the weekend. Okay, Saturday, Sunday, because they are all working, right? So over the weekend they will be delivering the
Yes, yes,
sessions. Okay.
yes.
Now,
Yes.
important thing is that when we deliver the sessions, obviously trainer to trainer the things are different. For example, if you ask about me, you'll get to know I don't follow too much of PPT. Okay, even I don't give notes also. What I usually do, for example, let's say I'm teaching floor planning. If I'm telling that we need to allocate area, that is the first step. I will open the tool, I will allocate area and done. See what my point? I'm telling pin placement. There are the rules for pin placement. So I will do that in front of you and done. I'm not going to give any notes, any PPT. Second way, there are trainers who will teach very beautiful from the PPT and then they will replicate the same thing in the lab. There are two ways of teaching. Okay. So first they will complete the theory, then they will give the lab. And the same lab session should be replicated by the mentors over the weekend or the weekdays. They will replicate it. The mentors are the one who are like students from VLSI who only they are now recently got job or maybe they are done with the course waiting for some job or something like that. You got the point? So trainer to trainer the way of teaching is little different. But yeah, lab we should teach you. I mean it will be told that the Saturday is theory, but it is not never a theory. There is nothing called theory in physical design. Yeah. What I will tell? I will tell that I will move this macro here to there. Theory में क्या पढ़ाऊंगा यार? I will show you ना if I move the macro it will go there. So there is nothing called theory actually. The theory should be replicated here. So I teach actually even I open the tool in the first class itself. Only problem is they have actually changed the server and all, so I don't know whether it will be connected or not. That's the reason. Any other question?
Yes. So my last question. I don't want to take another people's time, but my last question is, when will the course will start? Next month? Next week?
When is it starting?
अच्छा.
When,
This question I don't know. Bebo, did you join? Bebo? He has not joined. Manohar? I don't know that. So these questions, Bebo is manager here, so he will take this question.
okay. I will ask. I will ask the Manohar. So thank you for answering my questions.
Yeah, no problem. Yeah, any technical question? Yeah, sure. Technical तो पूछो यार. Any technical question? भाई मैं खड़ा हूँ
So,
तो
sir, basically we simulate the circuit with various parameters. We check the circuit, or we design the circuit. Like,
come back again.
uh, so, so for the job role for this is to design the circuit or to simulate the circuit with various parameters. Means to check whether it's working
Okay.
on this condition or not.
I got it. He's telling we will be designing the circuit or we will simulate the circuit. That is what he's saying. What is simulation? You know. What is simulation? So there will be one circuit, let's say virtually we are creating on the tool. After that we will test if I give the input, what is the output and whether it is functioning property or not. That is what the simulation is. But what we do in
Yes, yes.
physical design, whatever logical connection has been mentioned in the netlist. In the netlist it was mentioned no AND gate OAB. That means O is the output, A is the input and B is the input. And I am defining AND A1, something A1 is equal to O and B. So it will go in the library. In the library, it will say that what is the AND gate. Then it will see that in the library it is mentioned that AND gate is equal to Y equal to X and to Z, something like that. That it will map, and then in the real time, what I need to do, there will be one box. It will show AND gate, input A and B, and output will be like that. We need to design based on your this size netlist. Can you open the tool also for me if possible? Can you do that, please? Just give me server 20. Just I will take some 2 minutes. That's it. Yeah, any other question? I don't like if I open the tool. If I don't open the tool in any class. It has never happened till now. बड़ा अच्छा नहीं लगता, feel नहीं आता है. So if I go from here on the way, every time I think I missed that. I should have opened the tool. Because if you open the tool now, you will be fascinated at least to see that. Yeah, हाँ, कुछ दिख रहा है at least. Server 20, if I can get, it will be really good. Yeah, any other technical question? I will take it. I'm here for another 5-10 minutes. I'll go after that.
Hello, Joel.
I don't have any biscuits or chocolates, otherwise I would have given you.
Hello.
I can see your face. Yeah, please go ahead.
Yeah, Vaibhav here.
Okay, Vaibhav. Yeah, someone was asking about the duration of the course or something like that. Can you please go ahead with your question?
Right. I can. Hi everyone. I am Vaibhav, manager of VLSI Guru. So regarding the training, regarding the placements, whatever doubts you have, we can discuss now. Before that, just let me share my screen. Yeah, Joel, can you make me presenter? Hello.
Hello.
Yeah, Joel, can you make me presenter? Hello. Just wait for 2 minutes.
Okay.
Yeah. Yeah. So can everyone see my screen?
Yeah, able to see.
Yeah. So yeah. So let's begin with the question and answers. So as someone has asked about the duration, the duration is 6 months, and it is common for both the full week training also and weekends training as well. Now, in full week training and weekends training, what is the difference? So I would request please mute yourself. Okay. So for the live training, we have two kinds of batches. That is a full week training and the weekend training. In full week schedule, the training will be from Monday to Saturday, 9:30 to 1:30, where we will be giving now whatever live session is there. The session is getting recorded in the background. Even this session that we have conducted, it is getting recorded in the background, and we will share you this recorded video also, so that you can go through it once again, and if you have any technical queries, that also will be get cleared. Coming to the weekend schedule, this weekend schedule is mostly preferred by the working professionals or the candidates who are pursuing their final year. So in weekends, it will be 9 a.m. to 1 p.m. theory sessions, and 2 to 6 there will be lab sessions. Whatever videos we are conducting, the access to those videos will be there for the weekdays preparation. Now, most of the candidates are inquired for the physical design training or want to do this training with the motive of getting placed or into the industry, or at least to start a career into VLSI industry. Am I correct?
Yes, sir.
So I request everyone, let it be a bidirectional communications where we both interact with each other, so that your whatever your query is there, be open to your query. We are here to resolve all the queries that you have. So we have a placement protocol in such a way that since we do the industry standard projects, we have tied with almost 100 plus companies, which involves a combination of product based and service based. If I name few of them, then it is Intel, Samsung, Microchip, UST, LNT, even we have global foundries as well. Okay, so these are the multiple companies that we have tied up with. Along with that, see, they have a they have a frequent requirements of physical design trained candidate. So what we do is, during this 6 months of time span, we start from the basics of digital design, that is AND gate, OR gate, ones complement, twos complement. And once you reach to the 6 months at the end of the course, if you do the assignments thoroughly and if you proactively participate in each and every session, the candidate gets a hands-on expertise in project as well as the tool that involves Synopsys tools, which is a set of ICC2 prime time, RIC, even the Red Hop, where we use the two libraries for synthesis and STA as well. Now, after having expertise in this, we start providing the placements or the job opportunities to the candidate. We will be providing the opportunities till a candidate get placed. So suppose you are there is no restriction that we will provide only 5 openings, 6 openings. If you are well prepared, institute will support you till you get placed. Now, now when it comes to 100 plus companies, we don't entertain any startup companies. We only, am I audible to everyone?
Yes, sir.
Okay. So what we do is, okay. So basically what we are doing is whatever types we have, we make sure that it's a tier one company, that is good companies. So we will be providing you the placements till you get placed into that company. Now, when it comes to the job opportunities, what package you can expect? So, if a candidate is pass out after 2020 or fresh pass out also, they can expect a package in service-based companies. They can expect a package of 4 to 6 LPA. If they get a chance to enter into product base, if they perform well into the interview of a product based company, then they can expect a 6 above 6 LP also. But this is the package that you can expect after undergoing training from VLSI group. Now there are candidates who are working in some other domain now want to switch to VLSI. For them, the package depends on what CTC they are having currently. So someone, now we have example of a candidate who was in a teaching domain from 2015. So he has got almost, even he is having experience of 5 to 6 years teaching experience. Still he was able to get a 30 to 40% hike on his last previous salary. It is only because of the expertise that he has gained in the training. He has done the hands-on practice of whatever projects we have conducted during the training. Okay. Now, one point I would like to mention in the placements, there are 2 to 3 things that has to be considered, because even if the candidate is good in technical, he should be able to address the communications also as well as resume preparation. So that complete things will be taken care by VLSI Guru. We will conduct multiple mock interviews. Now, even we will do the resume preparations also and few presentation sessions that will give you the confidence of facing the interview. Now, this is a short explanation about the training. Now, may I know what are the queries you have?
Sir, I have one question.
Please tell me.
Regarding the weekend schedule, are you guys providing recorded videos or is the live session
See,
in Saturday,
really, the
Sunday?
way today we have session, this live sessions will be there.
Okay.
Yeah. Now, what happens is
So,
this session where the tool is required as well as the projects are there, there will be live sessions. But there are some sessions where suppose I'm doing digital design training. Okay. So if there are some basic, for example, digital design or PD basics, there we provide the videos, and on Saturday, Sunday, we will keep a session for doubt clarification. Because
okay.
for the basics, there are certain videos where they are self-explanatory. For example, if there
Okay.
is a video where I'm explaining basic gates, so we provide, if I don't conduct a specific session for the basic gates, we provide the video, and on Saturday, Sunday, we schedule a doubt clarification session.
Okay. Sir, one more query. So, how many days this, I mean, after 6 months, this material can be accessed? How many, till how long we can access?
See, apart from the videos, whatever course material that is PPT, PDFs, notes, interview questions, that will be accessible for at least 1 year.
Okay. Okay. So, videos cannot be accessed after 6 months.
Yes.
Okay.
Yeah.
Hello, sir. How many days it would be the basics were covering, and what are all the major topics would be covering on the basic session, sir?
See, basics will include digital design, Linux scripting, TCL scripting, PD fundamentals as well as PD basics. Here, while doing TCL scripting, we will be having ICC2 tool. So if I walk you through the
Okay, sir.
see, these are the topics that we are gonna cover in the 2 months of basics. Yeah. Any more queries? Any doubts regarding the placements, duration?
Sir, I have enrolled the course for the weekend. Okay, so can you please tell that? Okay, what the course fees? I mean,
See,
how many
the
times
course
we can
fee
pay?
for
Like,
course
yeah.
fee for the live training is 63,000 plus GST, which comes to 74,000, and you can make the payments in 2 installments. The batch will be starting from Wednesday.
Okay.
Now, the see, for those who are looking for placement assistance in the month of almost November first week, we have 2 to 3 companies that are coming, and they are having the requirements of if the candidate is good with the basics, the 2 months basics that we are covering, it will be they will be giving the offer as a pre-offer where after completion of the training you will be a part of the company. Okay, so someone looking for this one, you can take this as an opportunity to sit for the placements in the month of November first week also.
Okay.
Sir, by joining uh, PD session, can we access videos belongs to verification also or not, sir?
See what happens is whatever course you are enrolling, that will be only eligible, right? You are eligible to take that.
Okay.
Sir, you are mentioning that the full week schedule is from Monday to Friday, so 4 hours per day.
Monday to
So
Saturday.
totally 24 hours in a week.
Sorry.
But coming to the weekend sessions, they will be only 16 hours, right? So will we cover the entire syllabus in the weekend sessions?
See what happens is there are modules like digital design is one of the module. It is taking 15 days for live training. Okay, but there, as you said, there is a difference in the hours. After completion of every module, for full week candidates, we give a break for 1 week break where we align the syllabus of weekend training also. Because since it's a 6 days week, we provide a 1 week break after every module to revise them. And during that break time, the weekend training also align with the same portion. So at the end of every module, after a break, we make sure that both weekend training and live training, full week training are on the same page.
Oh, okay, sir. Okay, thank you.
So what about the tool access and all?
The tool access will be 24/7 till the course completion.
Till the course completion. What if I want to use that after course after 6 months
See, it depends
to
on
practice and all?
it depends on how much duration you want. If someone wants to
Okay,
use for 1 or 2 week more, we provide that. Now, if
okay,
someone wants to use 3 4 months, then there are some
okay.
nominal charges will be applicable.
Fine, fine. And one thing, sir, in a website you mentioned we provide PD course with a 14 nanometer, but the GSL told us like, hello,
Sorry?
I'm audible, sir?
Yeah, you are audible. Please tell me.
You mentioned that a 14 nanometer technology we are going to work with, but the GSA told us like it's in 26 or 28 nanometer, sorry, 28 nanometer and 32 nanometer.
Right. So actually what happens is there are certain concepts that we explain on 14 nanometer also. So you'll be giving exposure of
Okay,
28 as well as 14 nanometer both.
okay,
Yeah.
okay, fine.
Sir, is it is compulsory to decide for which course we are joining at the beginning?
See, the digital design is common for both front end and back end. So within uh, 15 days of joining, you can decide whether to move to front end or back end.
Okay. Sir, is it true uh, in physical design openings are very, very low, no openings now?
See, I will tell you, I'm the placement coordinator and mostly I attend a PD. If there are 100% placements in design and verification, then there is 85 to 90% placements in physical design. So
Physical design.
now, if you ask me which
Is there
domain
any
is having, sorry,
is there any variation in mm, salary increment?
see, there won't be any variation in the salary increment. If you ask me about the starting salary compared to design and verification, that is also the same. Why? It is because for a fresher to start, there is a protocol that company does, and whatever type companies we have, they provide at least 4 to 6 LPA. Depends on your
Okay.
performance, but the range is 4 to 6 LPA.
Okay. Hikes also be same for both front end and back end?
Right. See, actually, what happens is now it's not about the hike will be same in front end or back end. If you perform well, you can get a more hike also. Hike totally depends on the performance.
Performance. Somebody telling in PD hikes are more comparing to remaining analog layouts and also verification. Is it true or wrong?
See, as per the hikes are concerned, the hikes for both the domains are same. Now,
Okay.
someone getting more hike, they can make a comment that hike is more in PD, right? So, comment is something that is subjective.
Okay, sir.
Okay.
Is total videos can you provide at the beginning only so that we can complete within 2 months or 3 months?
Hello.
Is it possible
Yes, sir.
to complete
See
this
what happens
total course within 2 months?
see, candidate perspective, it should not be completing the course. Candidate perspective should be gaining the expertise.
Yes, yes.
Even we can provide someone doing the one-time payment, we can provide them the complete videos also. But if I give you around 140 to 160 videos, then when you will be making that? That is the question. So why we could
Okay.
do a one sequential exercise? Because suppose I give you digital design. Okay. After giving digital
Okay.
design, when you ask me for PD basics or when you ask me for TCL, I will conduct a test and I will come to know how much you are prepared.
Okay.
Yeah.
Vaibhav sir, if time permits, if at all we get some leave like 20 days, 25 days, can we come at office and in person? Can we study the? We will continue the training.
See, what we do is just 1 second.
Vaibhav,
Ah,
Yes, sir.
hello. Vaibhav, once you are done with this question, I will need some 10 minutes. I will just complete this thing and then I will leave here. After that, you can take the questions, okay?
sure, sure.
Okay.
Yeah, please answer this question. After that, give me 10 minutes, okay?
Okay, okay, fine.
Okay.
Um, yeah, please tell me. Can you repeat the question? Hello.
Yeah, sir. Sir. Uh, for the we opt for online weekend course PD course. So if at all we get a 1 month leave if my company approves. I will come offline classes and learn in the office.
So see, we have 2 to 3 modes of training, like online training, classroom training, even weekends training and full
Okay,
week training. We allow a
okay,
candidate to change as per their requirement. In live training, you can
okay.
go offline, online, either weekends or live training, whatever you need. We are allowing. We are, don't put any restrictions. Only thing
Okay.
is, whichever way you are comfortable, you are allowed to do that. But at the end, you should learn the things.
Yes. Yes. Thank you.
Jaul, you can continue.
Yeah, just 5 minutes, Vaibhav. I will quickly close it so that at least they will get an idea like what exactly need to be done. Okay.
Sure, sure.
Yeah.
Yeah. So guys, see, I just loaded this tool for you. I opened it using this putty. They will tell you the steps how to open it. Okay. So most important thing, if you see, I'm working on a Unix interface, right? It's a Unix, it's a Linux, right? So I'm not working on Windows. So all these things like ls minus lrt, pwt, whatever. So you need to use Unix command. So that is for sure. This thing you need to learn. Okay, that one point what I told is valid now. Okay, now coming here, if you see, this is the tool I have opened, icc2 underscore cell. So I told you will be working on icc2, that is also valid here. Okay, and someone was saying like you mentioned 14 nanometer, but Zia was saying 28 nanometer and all. See, yeah, whether you, okay, let them claim and let you also do a research. One thing I will tell you, any technology node you work first, it will be all same, but flow don't change. No, it is completely same flow, and the issues that you will be seeing in those technology node, we will bring that issue here itself. I am the one, I can bring it. All the sorts, open and timing violations, crosstalk, whatever is not valid there, it will be valid here. I will tell you the fixes, not a problem. Okay, so that question anyways is
Fine.
not a I mean correct question, to be frank. But now coming to here,
Okay.
I was talking about like the layout. So this is the window where you will be visually seeing how your design is being placed. Okay, so if you talk, if I was talking about macros, so these are macros. Okay, clear enough. And then if you see, once your macros are placed, this is the area they have created. Okay, after that, if you see in the flow, they would have placed these ports. These are the ports actually. Okay, output, o means output, somewhere I will be written. If you see here, I also is written, so that is input. Clear enough. Pins only, we call it ports at my level. Okay, so there is a difference between, slight difference between pins and port, relative term, we'll teach it later on. Now in the center area, if you see green color, blue color, something is there. If you zoom there, you will understand those are nothing but your cells, not transistor. You will not be dealing in the transistor level, you will be dealing in the gate level. At the end, this gate will be manufactured by the custom layout engineer using the transistors, and those library will be present with the foundries. Aya samajh mein? Is it clear? So if you see, these are the gates actually. Okay, so if you click this guy, it is showing OR gate. Okay, so if you see, this is like square shape, rectangle shape, different shape. But at the end of the day, you know about the digital circuitry. So if you see, it is a digital circuitry only. Okay, you can open in the schematic and see it, right? So connectivity wise also, it will show what is the connectivity, which gate is connected there, the output what is connected. So in the netlist, whatever is written, okay, that you can convert into physical form. That is what the physical design is it clear now? The written code, the synthesis netlist, is converted into the physical form. This, if you see, this is the net, that connection, the internet connection, interconnect connection. From here to here, it is the connectivity is there. So there will be different stages. So you will be doing the stages like this. Okay, if I show you here in this project, when I would have taught, so this project when I have taught them, I told them you do floor planning, you do power planning, you do placement. In each stage, you can save the design. So you can go back and check what you did in placement stage. You can go back and check what you did in. So in this way, we do the lab sessions here. Okay. So I will be doing the lab session and you will replicate it. See, there will be completely, everyone will get the flow. There will be tickle files. I told you, no, scripts will be needed. See, someone was asking, no, sir, it will optimize in placement stage. Then with respect to what? So these are the things I'm doing that. No, I'm telling that maximum density. Can you put it 45%? Can you use the SQ of 125 PS? The tool knows that. No, these are the constraint I need to meet. So while optimizing, tool will follow that. Based on that, only tool will do the fixes. Which kind of buffers it need to add? What kind of latency value? I mean, something is called latency, like how much time it will take to propagate the clock, how much value it is needed. All those things we can set up in the flow. So that flow will be already available in each and every company actually. Whether you work in MediaTek, Qualcomm, everywhere, there will be CAD, like EDA company that gives the flow. Okay. So now as a PD engineer, what is your role? You can source it and complete the task, right? So you should be understanding of this flow. If it don't go correctly, you need to debug all those things. So debugging is very important for you. Then you need to make a trial and error, right? If this is not working, you have to switch the things, right? You have to change the things. For that, you need to understand the tool also. For that, TCL is needed for you. Tickle. That is what the point I mentioned. Is it clear now? Pakka? Okay. To
So, sir,
summarize
by
the whole,
writing, sorry for interrupting. So, by this
yeah.
writing these commands, we build a flow. It's like
Yeah,
that,
yeah,
no?
see, any
Okay,
company you go, where any
okay,
company you go, already
okay,
there will be team to, they will be developing the flow. Okay,
okay,
like the one who are good in scripting, like I'm good in scripting. So I'm a part of a CAD development team also, right? Where I will be developing this codes for placement, CTS based on the technology, based on the complexity of the design. We'll be changing the script and make it. Like for example, here also I only made this flow. If you see this placement flow belongs to me only. Okay, so similarly, some other trainer they will make their own flow where they want to do some kind of different kind of experiment. For example, earlier some students complained me, sir, we are not seeing any big violations. I told, okay, let's make it. So I created the violations, all kind of timing violations, all kind of congestion issues and all. The issues we created, because if you don't create the issue, how I will show them how to fix it, right? So I developed this flow. So similarly, there will be big I mean companies where good engineers will be there. They will develop the flow. Okay. So this is just the, I mean, just I wanted to show you the tool so that you will be fascinated actually. At least like kuch acha hai, something good is there. Okay. Now quickly I will, yeah, quickly I will close this session with one small thing. That is what I was thinking that time. Like since you are asking a lot of questions related to this company placement and all. See, one very simple thing it is. I'll just close it here. See, there will be companies which will be generating the product. For example, Qualcomm is there. Qualcomm will make the mobile. Okay, clear enough. So now they want to make the mobile, let's say Snapdragon 888 they want to make. So it will go through a complete cycle that we discussed, idea and specification, some designing, something we discussed. Clear enough. So for that someone who is good in front end, someone who is good in back end, with that we will hire the engineers from reputed college like IITs. I mean that is what the product based company does. Don't get it wrong, but they will hire from tier 1 and tier 2 colleges. Clear enough. Now you think in this way, one project is there where writing of this front end coding takes 3 months. Okay, but PNR is taking 6 months, assume that. Okay, so for that remaining 6 months, what is this front end guy going to do? Maybe we will working on some project, or some will be there who will be not that much lightweighted work will be there, right? But when you hire someone from tier 1 and tier 2 colleges, you are paying a very fat starting salary, right? Some 50 lakh 60 lakh packages, you have heard that, right? So for that bench time, when they don't have big project, why should I hire a bulk engineers? Rather than what we can do as a, I mean, business model, we can take engineers from some company till the duration of that project as a contract basis, and after my work is done, I can tell them you can deploy them in other project, I don't need them. So that is a good business model, no? And for that company also it is very good, because they will be giving their engineers for some time in a reputed company like Qualcomm, Intel or something. They will gain experience, and future they will generate the revenue. So that brought the model of service based company. That is what mentioned here, service based, right? You're able to see the screen? You're able to see? Okay.
yes, yes.
Now when I was talking about the IPs. So there will be company which will make IPs. Okay, directly we will be using the IPs that will be used by service based company or as product, because anyways at the end of the day both will be working together only, right? Is it clear? Is it clear? Okay. Now there will be company which make the tool, like Synopsys, Cadence. This tool we make. Okay, the engineers like us who are good in their app development and all those things, right? Even there will be engineers who will be supporting with that tool. For example, I'm very good with my commands. For example, he asked, "Here, what is version?" I started quickly with the command because I remember a lot of commands from different tools. I work on n number of tools. Okay, to be frank, whatever is available in market, I work on that. Okay, so now he's telling I'm using the commands, right? So that is in my mind, so I can be a very good application engineer in future. That if Synopsys tool is not working properly, you can reach out to me, I will work for you. So Synopsys will be hiring me as an application engineer. So from VLSI Guru only, I think some 20 plus engineers whom I have taught, they're actually working in Synopsys and Cadence. So you can also go in that field also, where you will be working on these tools only. But you should be good in scripting and again debugging skills. Is it clear? Now, quickly, I mean, just for understanding purpose, these are some of the product-based company, okay, like Samsung, Intel, SK Hynix, Micron, Qualcomm, Broadcom. So believe me, I mean, if you don't want to believe, do a research also. From this institute itself, like 90% of the companies has been covered where the at least my students are working. I know them personally. Okay, so obviously this institute's students, right? My student means I belong to institute only, right? So I know them personally, that's why I'm telling. Okay, so we have chances where you will be directly getting I mean good companies also. There are direct employees for Qualcomm, Intel from this institute itself. We have given that placement actually. And anyways, for services we are open. We have like our I mean partners, working partners with a lot of companies actually. Baba would have told you, right? He will also tell about those things. So we directly hire from here. So I'm seeing a good placement from last 2 3 years. Very good placement actually. Okay, and I don't know whether you know or not. I was the first student of physical design from VLSI group when they started. Okay, I think 2016, 2015. I was here. I was the first student. Okay, so now see where we have gone. So wow, I mean just to summarize it. So these are the companies which are EDA based company. There also you can go and work. You got it right. So we will give support.
Yes,
So
sir.
yeah, this is what I have as per technical things. Now non-tech, Babo will take. I hope you got an idea of the tool, and you got a little bit of idea of companies also, right? Yeah.
Yes,
So
sir.
I concluded in 5 minutes. I didn't take more than. Okay, Babo, you can take forward from here, right?
Yeah, thank you, Joel. Yeah. So we were discussing about whether you join online, offline. As I said, you are open to switch to any online, offline, weekends, light, full week. Okay. So
Yes,
any more
thank you.
questions? Okay. So basically, I hope this demonstration has helped you with regards to what you're gonna do in this 6 months, as well as after completion of 6 months, what is the skill set you're going to achieve and how it will be helpful for you to get into the industry. Okay. Now, and
Yes.
even I explained you about the schedule as well as the placements. So what VLSI Guru is expecting from you if you enroll for this course, we expect only two things from you. That is, do the assignments regularly, and whatever training modules we are doing, you should be practicing it. That will be more than enough sufficient for you to get into the industry. Yeah. So, is there any more queries? Anyone? So, if there are any, okay. So, yeah, Gio,
Yeah, Babo, I am done. I'm done with everything. Okay.
there is a question that will you teach from RTL to GDS2?
Yeah, yeah, yeah. From RTL to GDS full flow, I have taught. I gave them at least an idea, so they will be now from here able to take the decision what need to be done. Okay.
Oh, okay, okay, sure. So
Yeah.
I
Okay.
hope Sir Raul has also addressed all the queries as he has shared his number also. For any technical queries you have, you can directly reach out to him for your technical queries. But since he is a working professional, if there are any queries regarding the duration or what notes and everything, whatever non-technical you have regarding placements, I am also sharing my number. Okay, you can reach out to me on this number. If you're not able to reach, drop me a WhatsApp message. We will make sure by end of the day we will respond to the message.
Fine.
Sure. Yeah. Any questions? Anyone? Okay. So as I
Hello,
shared
sir.
my number also. Yeah, please tell me.
Uh, Sir, is there any chance that the product based will be hiring the MSc electronics based on their skills?
Hi Shweta, as we discussed on call also, see, there are chances to get into the product-based companies also. It's not about whether you are MSc Electronics or a BE candidate. MSc Electronics is equivalent to a BE also. So if you perform well, yes, there are chances to get into the industry. What assurance we can provide you is if you are well prepared, whatever openings we have, whether it's a service based or product based, we'll put forward it to you.
Yeah, I will take this question, Bebo. See, directly product-based companies are not coming to this institute, right? But since Srinivas sir is also having very big reach actually, and I am also having very big reach. What we do, or the one who are really good, our engineers, I mean, the students who will get to know, right? From one batch, some five, six guys who are really good. We will forward the resume. So there are like some. I'm telling you, there are some 50 plus students whom I know they are working in QC. I have seen them. I will meet them whenever I go for lunch. They will be like hi hi like that. So I met a lot of guys. So they are doing good, right? So you will get a chance. Only thing it is like reference. Directly company don't visit like institutes. Cadence synopsis we can get it, but real like Qualcomm, Intel, Google they will not come to your institute. But with reference you will get it as simple as that. Okay.
Yeah, one more, Jewel, what happened is, I like all candidates. See, we have Intel and Samsung came in this. So we have seen in just 1 or 2 months back, Intel as well as Samsung visited this. As Jewel said, yes, through reference it will be there. But any product company that visits us, definitely we will support. Or through reference also we can support. Yeah. Any other queries?
For online weekend students, when is the next class?
It will be on 1st of October.
So Saturday, right?
Yeah, right.
Yeah.
So see, the even for weekend students, since we have made the batch will be starting for full week is Wednesday. The endowments will be open till Wednesday, and I hope all of you has filled the demos registration form. So I will be sharing the link also of this recorded video, so you can go through it again. And before Wednesday, please make up your decision so that you can start attending. For weekend students, once you enroll before Wednesday, we will provide you some e-learning access as well.
And the tool access will be given after.
Now, once the candidate enrolls for even weekend training or live training, he will be starting with digital design. In digital, there is no need of any tool. So what we do is once they come till TCL, then we start providing the tool access, because till TCL, no tool is required.
Okay, thanks.
Yeah. Any more queries? Anyone? Okay, so as Giaul and I have shared the contact numbers, you can reach out to us for if you have any queries beyond that. See, more or less you can learn the TCL basics, but whatever TCL training we are providing, and coming to the TCL from other resources, I'm not sure how much expertise you are getting from them. But the course structure I have in TCL, it makes sure that you have a expertise that is required for a physical design engineer.
So Bebo, if there is no other queries, can we please sign off for the day?
Yeah, sure. So
Yeah.
we will be signing off for the day now, and you can reach out to me on the number that I have shared. We will be providing all the details. Thank you all.
Sure.
Thank you.
Thank you,
Yeah,
Jay.
guys.
Thank you so much.
Thank
Bye.
you, guys. Thank you so much. Bye.
Thank you.
Thank you, sir. Thank
Have
you,
a
sir.
great day.
Same to you guys.